So welcome to the Boost. We're doing some more Go programming today. We did the 8 ball, which is misspelled. Let me fix that. We did the 8 ball last time. EIGHT. Magic 8 ball. It was really fun. Some of you may have done some extensions on your 8 ball and made it pretty and done some of the terminal colors and all that stuff. It's a fun exercise. We covered a lot of things during that, and we're not going to revisit those. So today we're gonna get kind of into some of the deeper stuff with bases and what that is. And you got to remember, with this beginner boost, this Go beginner boost that we're doing is designed for people that are originally 9 to 19. So that includes young people that may not even know what a base is, or let alone a linear algebraic equation. So there's not a, it might seem remedial to some of you, but that's what's here. So we're going to go through and do that and practice some Go along the way. Just a note of reflection about how we've been covering Go in the Boost this year. I've made the decision as of now that in 2023, the Go stuff will be not included in the beginner boost anymore. So I know a lot of people are going to be sad about that, but we will be doing. So this is the last year, as far as I know, unless something really radical changes, that we will be doing Go in the beginner boost. We'll be doing Bash. We're going to be doing more Bash, actually, and that will be the only language that we cover, and we'll call it the Linux Terminal Beginner Boost. And it will be fundamentally focused, as it always has been, on getting you up to speed. And that will include covering things like Docker and VMs and doing basic scripting with Bash, which is enough programming to get you going into another thing. And then we'll have another boost. We'll have a Go Beginner Boost, a Golang Beginner Boost. Or we'll just have a Golang boost, which means, because there's a bunch of things in the Go thing that we're not going to probably cover. Like, we're not going to be covering some of the concurrency models, select. I mean, there's a number of things in Go that just don't make sense for absolute beginners to learn, and so that's something we talked about quite a bit. But it did leave me kind of wondering how much of this we want to finish this year, because it's going to take us until December to finish it all. Hopefully not, but we'll see. So if we can knock out 4 or 5 of these by that time, we're going to go ahead and do that. And we might actually trim some of these. So like the Gen Greet Creator RESTful API, that's not happening. We're not doing that. Not in this one. We'll do that in a different thing, but not here. The story game interactive program with the random events, that we might do. That might still be on the table, but it's more likely that we're going to end after Pomo. And because the interactive story with the random events is like concurrency and a bunch of stuff. And in fact, I'm going to just decide we're not going to do that. It's just too much. It's too much. We need to get going, because we've got to still do web development and getting a job and reaching out and doing stuff like that. So that's all stuff that's going to be in the beginner boost. I've considered actually factoring out the get a job, get your resume ready, become a press and technology professional as its own boost. All that stuff about getting a job and preparing to make a job and talking about getting hired and networking and all that stuff. Traditionally, that's been something I've always included in the boost, but I'm now starting to think that also needs its own boost. It needs to be factored out, and it needs to be in its own, really intense, get hired, whatever you want to call it, consort boost or whatever. And then the Linux terminal boost would be just about the Linux terminal bash and everything like that. And so we'd have these like modules. So, I mean, I've always wanted to do that, but every time I do that, somebody wants to do more, and I end up overcommitting and putting more stuff in there. So and this is about the time when we would stop the boost, because I had made such a realization last year or the year before that. Another very important realization that I've made is that you can follow all this on the 2023 branch, by the way, of GitHub. If you go to the GitHub Boost page, and you want to start following plans for 2023, there will be, it's not committed yet, but there will be a branch here for 2023. And that will include a number of other conclusions, including using Podman templates instead of virtual machines to get going really fast with the terminals. By far the fastest way. It's now supported on every operating system, just like Docker Desktop was in 2021. So we are going back to containers instead of virtual machines, particularly given the problems with virtual servers, virtual machines not working that we had this year with VirtualBox being totally broken. And not supported on Apple. Podman is supported on M1s and everything else now. So Podman Desktop is the thing. So hopefully that's been a rough overview of where we're going. As I've said before, the last thing I'll say about this industry is dynamic and fluid and changing all the time. So this kind of stuff this is why we have to have a boost every year. Because the nature of the technology changes literally month to month, and trying to have the same curriculum or course every year is foolish. It's just foolish because you're not going to be able to do that. And so next year, there was no Podman on the desktop, right? There was no Docker Desktop replacement. Docker Desktop was free last year. This year it's not. Podman wasn't any good like at the beginning of this boost, but now it is. So all of these things are the reasons that the decisions have changed. All right, so let's start out a new project. Let's call it Your Base. So the Your Base challenge is just to make a program that prints out, it counts infinitely in 3 bases: base 2, base 2, base 8, and base 16, otherwise known as binary, octal, and hexadecimal. And that is the first goal for today. So let's jump right in, and this actually should go pretty quickly. All right, so we're in 21. How do we make a project? So this is the part where you're going to make a Go project, right? Do we want to make this into a library that has a command that goes with it? Yeah, let's do it. It's small, but let's get into the habit of doing that no matter what. It's always a good idea to factor out the core business logic of your application at the higher level, no matter how small your application is. So let's do it right. So Go... We're gotta look at this big long thing here. So go mod, you guys remember this, right? Go mod init, and then what? GitHub.com, rwxrob, boost, weeks 21. And I mean, your path will probably be much simpler. And then what? So we got a go mod that's got all the right things in it. We're using 1.18. You should never use any version of Go less than 1.18 unless you're forced to. Frankly, 1.19 if you can. It's much, much better. Okay, so we've got our stuff ready. We're going to make a spot for our commands. So we're going to make a directory for our commands here. The command is, the name of our command is, actually, am I doing this at the top level? Oh, I made a mistake. What mistake did I make? Where does it get the name from? We covered bases in the bash thing, but we're going to do them again. Yep. We did, but I don't think we covered them the same way. Yeah, plus I also want to show you about the binary printf operator. So this should go fast. We should only be doing this for about 30 minutes. If you can get this done, yeah, we forgot a makedir, right? We need a makedir for your base. CD your base. Actually, no, let's move all our other stuff in there. CMD, go mod into your base. And because I screwed up, let's go back into your base. I'm going to go to mod. I mean, if you want to go see the bash, this is one of the reasons I don't want to overlap with bash and go. In fact, I'm strongly considering taking the boost challenge exercises and turning those into bash and making absolutely new projects for the Go projects, like REST APIs, Open API generation, Discord bots, interactive story games. That would be a whole new set of challenges that are larger projects. So just so you know, and these very simplified challenges will remain with bash, and we will still do them to understand what a loop is, et cetera, et cetera. And those can all be implemented in bash, including randomization. So we'll do that. Now, I'm just editing go.mod rather than doing another go mod init because I screwed up. And I'm going to put your base here, and that should work. You can go test, see if it works. No go files. Okay. So we're going to make, so we're going to have a your base program, and we're going to have a your base library. So we're making a directory inside of CMD now for your base. right? And now we have, again, we have a your-based library, package library containing functions, and we have a your-based command. And let's, I mean, we can get kind of silly with this. You can do cmd, and we can do main.go. And as I said, you have a really minimal Go. Let's just do this. Let's just say your base.run. That's it. That's all we need. And it doesn't even have one, so we're gonna put all of our code into a function. And we're just gonna use main to invoke the function. And not everybody does this, but I like doing this. So your base.go. We'll say your base, because now this is the your base package, not main. What's the difference? You should remember that, right? What's the difference between those? Let's make this, call it run. And I can just put here, would run your base. All right, now we can test this two ways. We can try to build it, right? So go, how about go install, which does a build and an install. .cmd, don't forget the dot. Your base. All right, so now it says, oh, I don't know about your base. Oh, no. Your base, whatever. Well, that's got a problem. What's my problem here? Your base? Nope, that's not it. Your base. Oh, we forgot to install it. There we go. Yeah, so that I did a save, and that pulled my import line in. So now we can do the install. It should work. There. Okay, so now your base, and we get would run your base, right? So that's the first way to test it. It's very user-driven testing, right? We'd have to have run the command. We'd have to write a shell script to test it. Or we can do a lot of this is review. That's why I'm going through it fast. Or we could actually make a test case, a unit test file for this, and put your base. We could touch. Your base test.go, which is the naming convention required. It has to be underscore test, and we can make a package. We're going to do we're going to do default to example-based testing because it gives you documentation for free, and we'll say func example run. Right now, this is actually something we can run because we'll be printing a standard out, and I mean, as long as we have a maximum number. Which I think we should probably do by default. So what is the output going to be? Let's say output is just blah for now. Nothing. We just want to get it to run the code. And then we do your base.run and go.test. And hey, look, would run it. Okay, so now we are at a place where we can actually set up our test to run automatically while we're doing our coding. And let's do that. Let's split the screen, get back into the right place, and run go entr test, which automatically does that. If you don't remember, we wrote that shell script some time ago. Here it is. vic go entr test. And it runs bash, it runs clear, and then runs go test anytime any file has changed from the current directory on down. So that is pretty standard. We covered that very well before. And there, we have our test, right? So we're going to let our test run every time we do any changes. So we can have our testing running while we're doing our development. And so your base test is here. We could, change this. If we said, would run your base, we'll actually pass the test, kind of falsely, right? And we're not really doing what we want to do. So let's think about what the output should be. So what should the output be? Well, it should probably be like we want it to count, right? So we want it to count to 1, and so it's gonna be like 1 over here, right? 2, 3, 4, 5, 6, 7. Let's count to 16. Okay, let's count to 16. How many have we got? 1. I'm not going to do too much of this because I know that I can just take the output and dump it in here. It's going to save me time. So I'm not going to do the whole thing. I'm just going to do this first one. Okay, 6, 7, 8, 9, 10, 11. I should have wrote code for this. In fact, I'm going to do that. Let's do that. Let's write code to write the code. for I in 1 to 16, do echo space slash space $I done. Bang bang bash enter. Boom. There we go. That's how you do it. Okay, so now we've got our stuff. I can actually write code to write. Iteration syntax. Bash's iteration syntax is awesome, isn't it? I love it. So the same thing in Nim, by the way. That's one of the things I really loved about Nim. I'm a huge Nim fan. I'm going to tell you. I'm trying to decide whether to do Nim or C at Christmas. Probably C. I really love Nim. Yeah. Anyway, so, whoops, we got too many there. So it's failing, obviously, but it's pretty easy for us to make that work. I mean, you kind of know exactly what you're coding now. For Christmas, yeah, we do see at Christmas. It's kind of a tradition, so yeah. So we're going to do a for loop here. And one of the things about this for loop that you haven't seen yet in Go is we've done forever loops that just go forever, right? But we haven't seen the for init check change syntax. So yes, I said that. I used the words init check change. This is a mnemonic that I'm going to cover. So I want you to say it with me. Init check change. Init check change, init check change, init check change. Okay. Init check change loops are for loops, essentially. And if you remember that, you'll know the three parts. It's really easy to forget those parts. Okay. So we do init. So then we have, I can't remember if we have parentheses actually at the moment. I don't think we do actually. No, I'm thinking about another language. So init check change. So init, what do we want? We want x equal to 1, right? We want to put a 1 in here, right? And then what? And then the check. Well, what are we going to check for? I think it's a semicolon, actually. I can't remember my code syntax. Holy shit. Expected to find a loop. Yeah. So, let's see. Find assignment. Expected Boolean range. Oh, right. Okay. You have to have the Boolean. So, init check. God, I cannot remember my for loops in Go. This is so embarrassing. It's because I've been coding and other stuff. For loop, Golang. Let's go look at some actual documentation. Here's the for loop syntax. Here you go. Here's somebody who knows what they're doing. Yeah, okay, there's no parentheses. So here's your init check change. Init initialize a variable, check the variable, and then change it. Okay, and the change doesn't have to be the variable, but it probably should be. So let's do it. So init is the thing less than 16. Is it less than 17? So we'll have it be bounded. How about that? I almost never use less than or equal to. I always use less than. And change. So then we're going to say, our C stuff is lame code pill. Don't get excited. Because I have to relearn it every Christmas. That's why I'm doing it. I easier for iteration. Oh yeah, I usually use for I. I usually use for I or N. Or X. It doesn't matter. The problem with I is it doesn't always display properly. N equals 1. Let's do N. I mean, it doesn't matter, right? I always do for I. I don't know if you saw that in my bash loops. I always use for I in my bash loops, no matter what it is. My finger just types automatically. Yeah, they're good. So don't do L though, because you never know how that's going to print out. People are going to think it's a 1 or something. You see I for the lowercase I. I don't know, man. So yeah, I use I for everything. Compilation inside of Vim. I'm not compiling inside of Vim. I would never do such a thing. I'm just running tests which don't require compilation because the tests do the compilation. This isn't in Vim. This is net. Yeah, we covered it already. It's the net ENTR thing. Go if you want to see the source. I'm using Go testing for the compilation, which does compilation internally. And then I'm doing something called Go entr test. This is just a stupid little script we wrote. It's a stupid little script we wrote that uses the entr to detect a change and then runs it. And that's in it. We're using a tmux pane. This is a tmux pane down here. I would never use multiple vim panes. I think it's stupid. People do it, but I think it's stupid. Doesn't matter. So anyway, so here we have this. So how do I print it, right? So if I just print I, we're good to go, right? Look, we pass. Oh my God. We passed, right? How do we know we passed? Well, we did, right? But if we want to do something fancy, we want to say, line or something, put a string here. You got to do a concat, and then we're going to have problems, right? We're going to have problems now. And I want you to see that we're going to have problems. So strict typing can be a pain in the butt sometimes. Because why? Because now we don't know what type it is. So generally speaking, I tend to go with printf for printing. Because why? Because printf handles exactly what you want very elegantly. We've already covered this before. So v, right? We put a comma here for v. And as long as there's an I there, it'll match it up. We did printf in bash as well. Same thing. And we're not going to have a line return though. So watch how it's going to be wrong. See? If we go down and look, if we zoom in on our results, see what it did? No line returns, right? So we need some line returns here. So you got to explicitly put a line return. And now we get, something that's also not correct. We got the line in front there. Yeah. But it's closer to what we want. But what I want to show you though, is we can actually leverage this. So V, we've talked about this before. You can go read about printf. If you want, you can go read about printf. I just did capital K on that. And you can see printf formats according to a format specifier and writes to standard out, right? And we can go down here. That's all we have. It doesn't tell us everything. V is better than D in Go. Yes. V is the idiomatic thing to use. Because why? Because V means, you can go read about this, Go doc fmt printf. I think it might be covered in sprintf actually. I'm trying to figure out where. There's actually a description of all of the formats. If you just do Golang printf format codes. I want to see where they're covered. I don't know where they're covered. So scanf function, printf and scanf function, the printf function. We're gonna go find it. I'm trying to find the actual docs on it. String format in Golang. Oh, is it in the docs? It's in the official docs. This uses D. I would never use D though. Because I want to see it as a string. Yeah. I mean, D lets you do different things. You can pick. There's lots to pick from. Yeah. The people who wrote the docs, by the way, are largely C heads. And most code uses V. Why V? Because V does the right thing. All right. And I'm kind of spoiler alert. Look at this. We have B and O, which other languages don't have. So it's kind of a spoiler alert there. And then we have V as well. So D is for base 10. We will use D, but D is for base 10 numbers. But what I wanted to show you is a format. You can actually force things into string format. You can using printf, you can actually, coerce, I guess is the word, into these other things. It is important though that we talk about the fact that what V is. So V is the default. It says, run my string, convert me into a string as, unless it's been deprecated, which God, I would hate that to be true. I see it's out there all over. Which explains, yes. So it uses, S is a string, forces it to be a string. V says use the right thing. Right? It's funny because this isn't in the examples. This is a really old set of examples. Yeah. Yeah. That's a bad example. That's a really old tutorial. Yeah. I want to find it for you. I do. I want to find it for you here. So I want to find you a good explanation. I know the explanation, but there we go. So hello Go. This one has it in there. The reason V is so nice is you just always use it. It just works. Oh yeah. Go is, most people suggest you learn C before Go. It's designed to be a better C. They've said that many times. It's actually on the front page, I think. Import tags are %v. This tag is used to print the value in default format. Actually, let's add this Golang printf form fmt package. Hack the developer. I'm gonna add this to our notes. Just give me a second here. So we'll add it to the README here. I usually put like a related section anytime I pull up a website randomly. There's your notes. This is where we got the V thing. And there's no definitive source for this kind of stuff. This is, you just go look it up. So printf. So the tag here is used with the value in the default format. So V stands for value. And the default format. Default. So default format is interpreted as many different things. If it's a number, it says, okay, let's print it as if it's a string. And we are going to talk a little bit about string marshalling, and it's probably, but suffice it to say that Go has really incredibly intelligent default behavior when it comes to any value that you can produce. And so almost always you're going to be using V. Almost always. And if you want to change that format, there's some things you can do by changing the field, %D or X or something like that, or B. But more likely, you're going to want to implement a string marshaller if you want it to look differently. And that's specifically for structs, which we haven't even got into yet. We did a little bit, but I don't want to get you into structs too early. They can be kind of overwhelming. So here we go. Here's the struct, by the way. Remember I was talking about not getting you into structs? So here's a struct. So this says, hey, I have a student. It's very C-like, right? A student is a struct that has two fields. One's a string and one's an int. And I'm going to populate that by making one and setting the values. And then when I print it out, you do %v, right? And you'll see the output from this. It uses a default format, output format, for a student struct. And when you use V, it uses a default. And by default, it uses Golang's internal marshalling for structs, which in my opinion sucks. I almost always overtake this with a JSON marshaller that I usually write myself, when I can show you how to do that if you want to. That's not for this exercise, though. We're not going to be doing structs yet. We will be doing this when we do the sort of Mad Libs activity, where we're going to be creating structs that are answers and responses and things like that. And then at that point, we might decide to re-implement this as JSON. I don't know why they didn't do JSON as a default, personally. It is a little bit more verbose on output, but they've created their own version of showing things. You don't care at this point, though, because for numbers, the default value representation as a string is always going to be what you want, unless you want to like tweak how many, spaces and stuff, which reminds me, let's get to that. So let's do that right now. This one let's call this one README. Okay, so we are back to where we were, and there's our good old loops. We already looked at that one. Marshalling is only for strings. Yeah, you can marshal binary data, but marshalling is primarily strings. Making something into a string and taking a string and putting it back into its native struct representation. That's marshalling in a nutshell. And every language does it. It's even for Python. So it's kind of a thing to get used to. All right, so I gotta make sure I'm in the right thing here. All right, so that's our challenges. And here, I'm just updating. Okay, and then let's go back into 2. Nothing there. We don't need that. So 1 is our main thing. Okay, so the long story short, use V, right? If you don't, if you wanted to put a 0 there or something, you could. In fact, let me guess at this. I think this is right, justified, and I think 2 is the way to get it so that it goes over a little bit. I mean, let's get rid of line here. Yeah. I'm zooming in here. I think I just indented it. No, I didn't. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 16. Why did it fail? That should not have failed. That's really interesting. It must be because it put some initial zeros on it, or at the end or something. Oh, whoops. Damn it. I killed my tests on accident because I'm going too fast. Okay. Yeah, go back to what we're doing. Go tests. All right, so yeah, that's interesting. It doesn't. Watch, this will pass if we just do this one. Was fail in the list of expected values. No, that was the top level thing. So something about the indentation screwed it up. You can read about printf. If you don't want that number to be left justified, I think it's dash. And I think the reason it's failing is because the example. Oh, that one still passed. That's nice. Let's try this. Let's try 0.2. I think that will give us. Now that one doesn't pass because we added initial zeros. Yeah. So we added initial zeros. You can actually do that without that though, and have it be 2 space indented. I mean, you can look at the formatting. I don't want to spend too much time on that, but this has got a 0 in it as well. That doesn't seem like it's the right answer though. Did I not save it? Let me go look. No, it's still doing it with a 0. That's interesting. I mean, that must be the default. What if we do 4? I'm just playing. That should do an initial 4. Nope. I got something wrong here. I don't know what. Anyway, so we're gonna need that in the one that's coming up though, because we're gonna do binary now. So the challenge at hand is to print them. Is it just 02V? I think that might be the default. Oh, no, there it is. Oh. Okay, so this is important. You see this right here? This is an annoying thing about example tests. It always chops all the white space from the first thing. So in order to save yourself when writing example tests from that hassle, make sure you put some word at the top of your test. So you could say something like, I don't know, bases, something like that, right? You need something. You need something here, and I mean, we could actually do base 1. You could say base 1, right? And that'll be fun. We're gonna have to do base 2 anyway, so or base equals 1 or whatever you want. And that will give you something to match here. And of course, we're failing right now because it's such a example tests. Example-based tests are, yeah, we've covered example-based tests quite extensively. So we're going to print our headers. So let's do that. Print. Let's just do println on this, and we'll do base 1. Okay. Now that should get us closer to passing, but not quite. See, it wanted base 1 and then 1, 1, 2, everything like that, right? And see how it's indented there? It's going to be a little hard to do that. Why is it hard to do that? Because of how example-based tests truncate initial lines. So I'm actually kind of intrigued by this. I think we can get away with the space here, though. I think I might pass. Let's check. Yep, there we go. All right, so that's nice. Now, we want to do that. The reason that we want to do the indentation is because we're going to make a big point about this, right? So this is just putting a 1 here. Okay, so now is the time to talk about bases. A base in math simply means the number of digits used. We talked about this already 3 times in this boost. Is the number of digits used to represent a thing. Okay, so I'm not going to belabor that point again. It's the number of digits used. And in base 10 digital, we use 10 digits, 0 through 9. So the truth of the matter is that we're actually not counting from 1 here. We're starting with 0. And that's why you see starting with 0 in numbers so much. So this is kind of wrong. Let's do I equals 0, which we really don't even have to do. And we do I is less than 16. By the way, one of the reasons that I like counting from 0 is because this number here is always the total number of things, because it's the upper bound, and because you're using 0, you automatically get an extra number in there. So you can look at it very quickly and see this is a range between 0 and 16. It never reaches 16 because it comes up to reach it. And we did interval notation the other day. So I++, right? So that is the easiest for loop to write. And of course our test fails now because we went with 0 now. So this is now going to be 0. And truthfully, 16, not really one of the numbers, is it? But we'll get to that. So, 16 is the upper bound. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we go back to 0 again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6. We put a 1 over here. So the way that human beings count, when we run out of all the digits that we have to use depending on our base, so base 10, that's 10 digits, 0 through 9. When we run out, we stick another digit to the left of it. And then we do the whole thing again. And I mean, that seems rather obvious, but that's what we're doing. We just keep going through our digits, and we keep incrementing the thing to the left. And this is how counting happens in all bases, whether they be base 10, which is probably based on the fact that we have 10 fingers, or base 2 or whatever. All right, so I don't know why that's not passing actually. It should be passing. Why are you no passing? Base 1 want got base 1 0 1 2 3 4 5 6 7 8 9 10 1 2 3 4 7 8 oh 15. Yeah, we don't want 16 to be included. Yeah, we don't. I don't know. I mean, it's kind of important that people do see 16, but 15 is the maximum, right? This is why you have 255 instead of 256, for example, right? Because you're all the way over the edge on that one because of the 0. So let's go ahead and shave that one off, and we should be fine. Yep. Okay. So we're passing. Now the other stuff is pretty damn easy. So especially if it can go, we want to add we want to add base 8. So as you can imagine, base 8 has, how many does it have? We're going to need 3 for this actually. 8 only has 8 digits from 0 to 8, 7. 0, 1, 2, 3, 4, 5, 6, 7. And after that, it trips over. And I'm just gonna show you straight up. If you want octal, you just put O there. It's either a small o or capital O. I can't remember which. And we just put the same exact number here. So we add that number. And now we have some really interesting output. Right? I mean, we should anyway. Maybe I did it. It's O. O is wrong. It's capital O. I think it's capital O. Is it capital O or lowercase o? Oh, no. I had it right. It was lowercase o. Robert. Okay, so we pushed everything over by 1 space and then 3 spaces. So we have it going all the way down to 17. So as you can see, the counting is the same up to 7, and then it trips over. It's like, oh, we're at 10, right? So now we're at 8 and we're counting. Boom, 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 boom. Right? And when we get to 15, it's actually 17 in octal. Right? So, and now we can add hexadecimal. Hexi, 6, decimal, 10, 16. So we can do that. Now, hexadecimal is X. So we'll do 3 on X as well. And we actually have to add another I here. Same I, just represented differently. And you'll see this is, there you go. You got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And actually, if you use capital X, it'll do capital letters if you prefer. So there's a hexadecimal. But one of the things that's really great about Go, and we can't do this in Python, is Go also has binary. So you can use B, and it will show you binary, which is base 2, right? And I put this at the end because, I mean, I don't know whether we should do it at the beginning or at the end. Should we do it at the beginning? Let's try at the beginning because it's kind of logical that way, right? I think we're gonna need we're gonna need, for binary going up to 16, we're gonna need 2 full bytes. I think we're gonna need 2 full bytes. We're probably gonna need 16. Let's try 8 and see if it's enough. I doubt it. Yeah, it's gonna be pretty long. So then we have, there we go. Yeah. Okay. It was long enough. Good. It is only 1 byte. 16 is only 1 byte. I guess it is. That makes sense. Yeah, that makes sense. It's 1 byte. 1 byte being 7 bits plus 1 bit for signing, plus or minus. So there we go. They all start at 1. And now if you want, we can, get crazy and we can put the base above it. We can put bases. All your base, just for fun. And then we can do, Python format can do binary these days. 8 plus 4 plus 2 equals 15. That's right. And so then we do, so we can actually, here we can put the number and just kind of fudge it, We could say what base number it is, right? So we could say base, and we could say, I mean, how many is that? We went over 8. We don't need 8. We actually need 5 probably. I think we only need 5 there. Maybe 6. Anyway, so this one we could say is base 2. You just use bin. Yeah. There's, and Perl has it too. It's got a pack function that does it. So base. All right. So let's actually add some things here. Let's say 1, 2. We're just making it pretty at this point. We're just making it pretty. So we have base 2, and then we have how many spaces? 1, 2, 4. 1, 2, 3, 4. So 2, 8, 16, and I think that's going to be a formatters. I do like that they do them as formatters. I do like that. I won't lie. So let's get these to line up just for fun. We could probably put some color here if you wanted to. You remember color codes, right? I'm not going to do that. And did we get that right? What are we doing 2 of? Oh, that's decimal. We should probably put decimal in the right order. So V is decimal. And let's actually change it to D. Oh, wow, look at that. Yeah. So let's do, so okay, so we have binary, octal, decimal, and hexadecimal. That's kind of in order, right? So 2, 10, and 16. No colors. I mean, we can put color on if you want. We can. I just color is juvenile. No, I love color. Wow, I almost got it. It was very close. All right, here we go. All right, so we are 2, 8, 10, 16. So we count 1, 2, 3. I mean, I just love looking at this because it shows you how close the numbers are to one another. And if you put initial zeros, they all have initial zeros if you want them to. And now you understand the joke. There are 1, 0 type of people in the world, people who understand binary and people who don't. Get it? You can make a lot of other jokes here. We've done it before. So you got, this is 10 over here. I think it's interesting where 10 appears. So 10 is like the 1, 2, third digit. 10 is the third digit in 2 in binary. 10 is the 8th digit. Is that right? No, the 9th digit. So it's 1 plus, it's the one after the base, right? So if the base is 2, the one right after that's going to be the one, the 10. So if the base is 8, then it's 7 plus 1, so the 10, the 9th ordinal, yeah. In the 10, it would be 9 digits, and then the one after the 9th digit is the 10. And if it's 16, it's like 16 digits, 0 through F, and then after that it would be 10, which might be worth showing. Let's actually do that. Let's go show that. Binary 101, it turns out it's a level 5 course. So let's actually go all the way up to 17, which is kind of cheating, but it does show you if you're kind of out of bounds at that point, right? So now we've got, there we go. There's our 10. We should actually, it would be funny because we could actually make the 10, if you wanted to get crazy, you could make the 10 red, right? So there you go. And that's why we wrap around numbers all the time. 20 for here. 16, that's interesting. 12, 13, 14, 15, 16, 17, 20. Why does it jump to 20? Goes to octal. Because it's octal, that's right. That freaks me out for a second. that one really freaks me out. That really looks like a bug. It's not. That doesn't it? Doesn't it look like a bug? 17 to 20. What? Because your digital, your decimal brain, is like taking over. 15, 16 is like, that's what it should be. F10. Yeah. Anyway, so these are numbers you're going to be working with every day, all day, pretty much in coding and in Linux and hacking and everything. So it's kind of fun to write a little program that kind of shows you all of them. It's kind of a reminder just to show it. And we're done. We're done with that one. Let's go ahead and take a break. I'll go ahead and save this code if you want to do. Well, I tell you what, let's get our test case to work. How about that? So we're going to cheat. I know you've done it. We've all done it. I'm going to take my test output and I'm going to put it into my test so my test passes. Strictly speaking, I should have written all that shit out and then done the test and made it work. But I knew it wasn't that big of a deal, so I'm a cheat here. I am not proud. I'm going to cheat. I'm just going to put it right to output because I know it's right. And because we have some problems here because I need to push it over. And you can use whatever method you want to this. I have a thing called I have a thing called go test output, and that just cleans up my output. It's a filter that I wrote. If you want that, I can show it to you. But now if I save it, we should pass. Look at that. It's amazing. Isn't that amazing? Okay, so there. We're done. And all we really need to do is call that now, right? Push it to production. Hell yeah. CMD your base. So we're going to go install to do an integration test, we'll say. Your base, boom. And we get our fun little cheat sheet. And yeah, push it to prod. So we're good. So we can do this. We can say git add your base. Actually, we get everything here. Git commit add your base. Git push. What? I forget my M. I did. Git push. That's kind of scary. Oh, I'm on the 2023 branch. Oh, I'm a bad person. I have to fix that. I'll do that during the break. So we're going to take a break right now. Don't mind us, YouTube. We're just talking about, death metal and Amaranth. I just got gifted an Amaranth sub. And so we're back to coding, though. I have my coffee. Wink, wink. Okay. It's only been an hour. Can you believe it? We knocked that out, man. And to be fair, we've already done that stuff, so I went through it rather quickly. It's Scat Man. I'm the Scat Man. I need to get better. Okay, so 8-ball, your base, waffles. Okay, so we could probably skip waffles. Waffles has kind of been a long time tradition. Now you could say Amaranth subs to my channel. Yeah. Oh, wait. They gave Amaranth a sub to my channel. Shit. I mean, something that I can say on YouTube without swearing. Pretend I didn't swear there. I mean, but wouldn't you swear? Anyway. Waffles. Okay, so as I said, these initial challenges were designed to be fun and for people 9 to 19. And I'm not kidding. I had 9-year-olds learning these things. And if you go to, so let me show you. Who knows the waffle song? I'm gonna play it. Yeah, I can't play it because YouTube is gonna like ban me. But I mean, I could. I don't care. It just demonetized me. So this was actually, this came from one of our members. It was like, we should code the waffle song. And I'm like, okay. 14 years ago. Talk about ancient memes. By the way, have you ever seen this? This is back when Rhett and Link were watchable. I just want him. I just want 12 of them. You gotta watch this. Go on YouTube and search for waffles. I just want 12. You'll have more waffles than Rhett and me combined. I just want 12 of them. It's so awesome. Anyway, so I know you were coming here to code, but this, we try to keep it silly. Also, it helps you remember, right? What are you going to remember from this? Well, you're going to remember the waffle thing, but you're also going to remember like synchronizing the waffle song. So we actually have to play the waffle song for you to do the waffles project. I know it's childish, but just hear me out.
Do you like waffles? Yeah, we like waffles. Do you like pancakes? Yeah, we like pancakes.
Oh my God, it's so loud.
Do you like French toast? Yeah, we like French toast. Dip, 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 can't wait to get them out. Waffles!
It's so loud, I'm so sorry.
Waffles! Waffles! Dip, 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 can't wait to get them out. Do you like waffles? Yeah, we like waffles. Do you like pancakes? Yeah, we like pancakes. Do you like French toast? Yeah, we like French toast. Dip, 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 can't wait to get them out.
As annoying that it is, that's been viewed over 30 million times. And it's something of a meme. So the reason that we're going to do it, you're like, why the hell are we doing this? Why can't we hack something? You might be old if you haven't seen that. The young people told me about this meme 13 years ago. So yeah, memes are old. Dank memes, deep fried memes, not really. It's just a thing. So the goal here is to write a program that emulates this, right? And there's really no your childhood. There's really no actual rules for how to do this. The idea of this is to just let people write it, right? And you largely have everything you need to do this, okay? But it's designed to get you kind of thinking interactively. It's sort of a mini story game. So the goal is to basically write the song and see if you can get the person to interact with it, right? And actually, if you really want to, even you can time the responses so that they match the song. And we've had people get very elaborate on this stupid little thing. But it kind of digs into the use of if statements and for loops and interactivity and prompting and color and all of that, all those kind of things. And I was watching a cartoon about waffles and pancakes with 73 other people. Mm-hmm. So I'm sure she gets gifted subs all the time. I'm sure she doesn't care. So it's kind of a state machine. It kind of is. I wasn't going to use that word. But it kind of is a state machine. So, do you like waffles? No. Okay, well then what happens next? So let's write it. All right, so how do we write every project? This is meant to be repetitive. How do we start any project? With a directory. Make directory waffles. cd into waffles, right? Go init. What? We're going to have github.com. You have to have your thing. artifacts rob /boost /weeks /21 /waffles. Oh, that's nice. Is it a 2FA 2OTP generator? Nice. I keep getting... That's cool that you can write that. Go mod init. Thanks. So, yeah, go mod init. This is a way for you to test yourself. I'm just kind of going there because I feel like you should know this by now. So we're doing a go mod init. And not go init. We're doing go mod init. Good catch. And then we have go.mod. Let's go ahead and make our command directory again. Well, this time let's do two at the same time. Let's call waffles. We're going to have a command call waffles. And we're as before, we're going to have a main.go that does one thing and one thing only. It just calls our waffles program. So we're going to put a run program in there, waffles.run, just in case anybody else wants to run their own and call our library with the run command. I mean, I don't think they would, but you know. And it's going to have a problem now. Why does it have a problem? What's missing? What's missing? A little bit of a test here. What's missing? Why doesn't my editor know to add it? Because it doesn't exist, right? So we're going to need to go back to that thing. So let's do it. Let's make, I use the convention of naming any package library the same as the name. And I always gave waffles to tier 1 sub. That was nice. So we're going to change this package name to waffles. And we're going to save this. And we're going to change this to run. Run, and we'll say, we already know one thing we're going to have to ask. Do you like waffles? Do you like waffles? And, okay, there we go, right? Now that we have that as a package, our Go editor is smarter. I can resave this. All I have to do is resave that same program, and boom, it can pull it in. Why? Because it now knows it's a package. It says, okay, I'm going to help you out. If you don't have that, God help you, because it is a pain in the butt to manage that. So waffles.go. Do you like waffles? In fact, we can practice our build. Go install, which does what, by the way? What does go install do? Just test yourself. What does it do? Obviously, it installs it. Where does it put it? Well, let's find out. Don't forget the /cmd waffles. And we're going to put waffles someplace. Which waffles? Okay, we'll put in my local bin. Why would it put it there? Oh, I don't know. Maybe because go bin is set to user local bin. Right? So we've covered all this stuff before, but this is a good review. So we got waffles now. Waffles. 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 Do you like waffles? Yes, but you didn't let me answer. You better write the program. Now, this is one of those programs that you can't really test it through the test API because it's interactive, right? So I am not going to attempt to write a unit test for this because it's an interactive test. And unless you're using something like expect or fabric or anything that actually allows interactive, standard error submission, which you can do if you want to get really involved. Maybe we will. Maybe we'll at the end of this we'll say we'll take over standard input and we'll turn it into a string, right? And then you can actually test it. In fact, this might be a good opportunity to do that. But for now, let's go ahead and get the thing done as a command like we would with Python, and then we'll come back and in this particular case, we'll add unit test case to confirm what we already know is working from our interactive test, just so it can be codified. Let's give that a shot. So waffles. Print, do you like waffles? Hell yeah, I like waffles. Okay, but it's going to be a question, so we already did this. We're going to just do it. We're just going to, without the ln, we're not going to print the ln, right? Do you like waffles, right? By the way, do we want colors here? Do we have a terminal library for colors? If we did, we could do the colors here. We could do red or something. But we're just going to do just a regular thing. We never actually... Did we make a term colors library? I think we did. Did we make a term colors library? How long ago did we do that? If it's already made, we're supposed to have already made it. I'm just going to try to find it. Precise. Yeah, I think we did already. Git crap. Yeah, we can take over IR Reader and Writer. It should be full accessible. Yeah, they should be. Should be. How's it going, Kent Down? So, I want to say we do have a terminal colors library. I just can't remember where it is. I can't remember where I put it. Where did we put it? Was it week 3? Normally you have a library. We do have a library installed someplace. We just have to go. There it is. Term colors. Term colors. Yes, term colors. In fact, watch. Go doc term colors. Oh, we don't have any. What week? It was week 19. Okay, so let's do that. Let's go. We're going to use our term colors library. Why the hell not? Okay, so we'll go to 19. Make it fun. I know I keep cutting corners here but it's actually fun. The kids love the color. All right, so term colors dot go. There you go. There's your term colors. And let's try to use our term colors, shall we? Let's do it right now. Yeah. Let's do it right now. It's their Greek parents and their geeky parents. Yes. Exactly. So the waffles. We're going into the waffles. We're descending into the waffle zone. All right. So there's no test cases here yet. So actually, we can get rid of that. And waffles. Let's use some colors. Let's say I want term colors dot red. Yeah. Plus. Is it going to do it? Damn it. It didn't do it. Maybe I have to install my term colors library. Yeah. I do. So go install. All right. How about now? Do we not have red? What do we have? We should be able to use it. It should be automatically put in there. I guess not. What is the name of our library? Term colors. All right, so I'm gonna have to import this like crazy ass library, which probably should be its own library. But we're gonna do it. I'm gonna try it by hand and see why I'm having trouble here. All right, so let's do an import here by hand. It might not take, but we're gonna try. It might not take. Save, please. Wait, I'm gonna delete this because I don't want it to. Oh wait, it kept it. It kept it. Nice. Okay. So you have to go find whatever your path is to your other one, right? And that should actually work. Yeah. Now, we can't run it though, so we got to do the thing. You can go install. .cmd. You can go build if you want. Doesn't matter. Waffles, and then at the same time, let's go ahead and run it. We'll compile and run it. Do you like waffles? Oh, look, it doesn't have it. I have to go get it. So, here's a fun thing. Term colors adds the right term colors to make it colors. Yeah, we made term colors some weeks ago. Week 19 precisely. So, we have an option here. We talked about this before, but it's a good thing to review. If I go get it, what's it going to do? If I type go get term colors, it will go fetch it off the internet and bring it down and give me the latest one. Right? Well, that's fine. If you don't anticipate you may not have been the person who made term colors. In this case, we did. We were the people. We were the people. We made it. We made term colors. So what I want to point out to you is that there is a possibility that there is a color or variation that you may wish to change during this process. So maybe you want to actually edit 2 packages at the same time. Never fear, Go Work is here. So rather than go getting this, which we can totally do, we're going to use Go Work. We used Go Work last week for the first time, but I want to continue to use it because it's so important that you get this down, particularly for multi-package development, concurrent development. In other words, if you are making one or more things at the same time, and those packages are in different modules, even though you are keeping them separate during the development process and want to make sure everything's working before you commit any of it, Go Work is here to the rescue. So we're going to do that. So to do Go Work, we do Go Work Init. You have to do Go Work Init in any project, otherwise it has no idea, right? And that creates a go.work file. And inevitably, the first thing you're going to want to do is go work use dot. And the reason for that is because if you don't do that, the example tests and things can get a little weird because they won't look at the same package you're in. They'll, try to find other stuff. So you almost always want to do go work use dot. Now, in our case, we want to use this localized thing. Now, we followed a very strict organizational framework for GitHub on purpose so that we can do this kind of thing reliably no matter where we are, whatever our development machine is. So I can actually do go work use rather than forcibly add it to my permanent dependency, which I eventually will have to do. I'll have to get rid of go work later. We can do go work use, and we can say I want to use. Where is it? Well, we know that we're in what are we in? We're in waffles right now, so we can go up one level. And what does that put us? That would put us in the parent directory, right? I don't know. Let's go see where it is. So ls dash 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 dash. And so we want to go into 19 slash term colors, yeah? So that is the path that we want. And then we can do go work use dot slash 19 slash term colors. And what this tells Go to do is it says, anytime I see the import statement for term colors, let's first check the stuff listed in Go work. And if any of those packages match, they come first. Otherwise, let's do the regular thing and go out and look to the internet and see if we have it. If we don't have it, we're going to error out and tell the user, no, I'm sorry, I don't know about that. You're going to have to explicitly go get that or go import it or whatever, right? Go get is, by the way, is different than go install. If you are using go get to install today, you are doing it wrong. So says the documentation. The proper way to install any Go program from the command line using Go is go install path at latest or at version. If your program doesn't do that, or if your README says use go get for installation, you're doing it wrong. Go look at it. And that's not me saying so. That's Go saying so. The new standard has always said that was the wrong way to do it. Go get has one purpose and one purpose only: to bring in a dependent package into the current package and to checksum it and freeze it at that level of whatever it was brought in at. That's its only purpose. Go get has never been, nor ever will be, for installing commands. That's not what it's for. You're supposed to use go install for that. And they finally dropped the hammer on that, thank God. So we're going to do vi go.work. And so there we have we see that it uses these things. So what is that going to do? So now when I try to do my go build, it will actually work. It should work anyway. Because why? So we're going to do a go install. It's going to go ahead and part of that is compilation, and then it's going to move it into the bin directory. All those steps are all built into that. And it does it fine. And then it runs it, right? So it says, do you like waffles? And look at that. We got red now. What? Okay. So, time for us to expand on our waffles program. So we got our term colors in there. Do you like waffles? I mean, and the other thing too is you can actually, if you want to have it so that the stuff that the person types in is a different color. By the way, I don't want to type term colors all the time. It's annoying. So I'm going to alias that to C. I'm going to put C.red. I know you can be mad. If you want to, you can make it capital C. And then it would be like more, unlikely to get overridden. You can do capital C, C.red. And then we're going to do plus C. Let's say yellow, which is kind of like gold. Or you can do Y. I think we made aliases, didn't we? I think we have aliases even. Yeah, you can just do C.R and then C.Y. Should we try that? And then what? And then we need to read from input. Did we do that? How are we going to read input from the user? Hey, we already wrote that. Yeah, we already wrote that code. Where did we write that? Back in our other program. So that whole factoring thing that we did, starting to pay off, yeah? Because they're like, hey, I wrote that code already. I can just reuse it. I don't remember where it is. We gotta find it. So let's see if we can find it. So let's do git grep for. By the way, that eliminates all the .git stuff, so you don't get all that extra crap you would get with a normal grep. What are we looking for? We're looking for the prompt and the interactive thing. I think that's the thing that we named it, right? Example prompt default. There we go. So we already wrote a CLI, and it changes the repository name. Then you can use replace. Yeah. For that, there's a directive in the go.mod called replace, which will automatically replace any of the currencies in your source code with a new one. That's exactly what replace is for. And replace has been abused, by the way, and projects like Customize come to mind to do the work of Go work. And it's unfortunate because now they're permanently stuck on that. Yeah, there's a directive for go.mod called replace, and you want to look into that one. We are not going to have a need for replace at all. In fact, you should avoid using it unless you have that exact scenario where something has changed and you don't want to screw your whole code base over by moving everything. People have abused the use of replace, by the way, I want to say, including like one of the original creators of GitHub. I had a Twitter fight with him, kind of. He was like, I said, no, you shouldn't do that. He was using replace to use vanity domain URLs and stuff like that. So uses it to use their forked version of Go. Yeah, there's a lot of that going on, right? But you got to be really careful with replace because it can get you in trouble. Yeah, no kidding. The guy he wrote an entire blog post and tweeted about using vanity URLs and having them redirect to GitHub, so that you could use like rwx.gg/whatever, and then you would be importing this, personally owned domain instead of the actual place where it lives, and then deliberately putting replaces in all of your dependencies. And I told him, I said, this is an anti-pattern. This is a horrible thing. And this guy is like an executive over at GitHub. I forget his name. He's like a big deal. And I was like, that is horrible. Don't ever do that. She's like, whatever. Wants to upstream their additions, but they can't, are stubborn. Yeah, it's a problem. The Customize project is another one. Actually, I opened a ticket on the Customize project. I said, you've got like 13 uses of replace that are violations. By the way, if you use replace like that, it will stop it from compiling under Go 1.18 and above. And you cannot. So now the Customize project is permanently stuck on version 1.13 of Go because they did it wrong. They used these replace dependencies, and they're like stuck because none of their dependencies are willing to make the changes necessary. It's kind of a mess, actually. So just be aware that that's out there. Anytime you reach for replace, that's why I'm not talking about it. Anytime, why would it get stuck? Because the replace directive is not supported past 1.18 in the way that they are using it. That's a simplified explanation. And they've been abusing the use of the replace. Basically, in 1.18, they said no more abuse of the replace directive inside of the go.mod file. No more abuse of this. And they put their foot down and said, you can't do it. And ever since then, the projects that have been abusing it, such as vanity URLs and other things, and used to customize, they're stuck. So now they're stuck on previous versions of Go because their core dependencies refuse to update. They refuse to use it properly. And it's a problem. It's a huge problem for the Go industry right now, for the whole Go ecosystem. And Go did the right thing in 1.18. So when I say make sure you learn Go 1.18 and you do it right and you never look back, I mean it, because the stuff that is defined that you use in Go 1.18 and above is for the first time ever the real hard line in the sand. And there is a ton of technical debt out there all over. Writing a hymn file. Yes. So yeah, I mean, you can actually read the ticket that I opened where their official response was, we don't know what to do. I'm like, okay. Yeah, anyway, so just, I mean, you don't have to worry about it since you're just learning, as long as you don't abuse it. But I have to say all that when someone brings up replace, because just don't abuse use of replace, right? It's not a newbie topic, but since you brought it up, I thought it was worth talking about. Okay, so we wrote this wonderful CLI package that we want to use as well. And so let's do that. Let's actually do a Go work on that as well. Again, we don't have to do Go work. We could just, go get it and be done with it. But since it's, it's there, maybe we want to expand on it. Let's go ahead and add it to Go work for now. So we'll go back into 21. We're already in 21, I see. Okay. So, wait, was it 20? It was in 20? Okay, let's go read it. So we have the CLI. Oh, we did it last week. Okay. So let's read about our module that we made before. So we wrote a prompt module. In fact, let's read about it. Let's say go doc CLI. Oh, look, we got this thing here. Go doc CLI prompt. Remember this code I wrote long a time ago that I have no idea how it works anymore? Well, I've got documentation now because it's built into the code. Because thank God I did it at the time, that I did the right thing, and I wrote about the code while I remembered what I was writing. Be aware not to write the documentation too early, though, because you'll change the behavior, and then the docs will be out of date, and then you have to change all the docs, and you spend all your time updating the docs. So my suggestion here is start with a comment that roughly describes your goal of what you're writing before you even write it. Very briefly, not intended for final consumption. Go back to it, implement it, make all your changes, and then rewrite the final doc right above the thing, which always needs to begin with the name, by the way, of the function. And then you'll spend the least amount of time. This is a lesson learned through much pain and suffering. I cannot tell you how often I thought that I had the perfect function. I wrote this big, long, massive, 30-line document for it, ended up factoring it out into 5 things that were names completely different things, and the docs were completely irrelevant. So stick with stuff that's succinct and to the point initially, and then somebody else coming to code bases can at least get a sense of what it is, and then flesh it out. Don't forget to flesh it out, though. But don't get crazy. Too verbose. This is an idiomatic thing in Go, but is only the least amount of documents possible. Don't overdo it, and that's probably a good thing. So anyway, we don't need to know how it's implemented. We just know that they exist, and we can read about our docs here. So we have a prompt. Prompt prints the optional prompt by default and returns the string entered by the user. Now, the problem with prompt is it can't be colored, right? Wouldn't it be cool if we could color it? Remember that thing about Go work? Here's one of those opportunities, right? So we're like, man, I've been using color over here. I would really love to use prompt, but prompt doesn't have color. I want to update my package, but I don't want to break the package dependency yet. So I want to do some concurrent package development. Enter Go work again. Go work use whatever. I don't. In this particular case, I'm going to go copy the line because it's already there, right? So we're going to go use week 20, and we're going to use the CLI thing, right? So we're going to create a CLI dependency in our waffles thing, and rather than print do you like waffles, we're going to do prompt do you like waffles. Now I guess I could use color here. Actually, I might be able to pull this off. Let's try it. So, and it's not FMT anymore, right? Now it's CLI.prompt. So look at that. Look at that automatic inclusion. Why? Because my Go work resolved the path for me. It's like, oh, hey, you already have that installed. I'll go grab that for you. And now you got a great, pretty import. Anytime it sees this import, it sees the CLI on the end. Go work activates and says, oh, you actually want this localized one and not the one from go get. And it bypasses the go get warning. I mean, that's a lot to talk about, but that's exactly what's happening. So let's do go install waffles and run waffles. Hey, look at that. Undefined terminals R and Y. Ooh, wouldn't it be cool if we did that? Remember I said that we use Go work because we might possibly want to change our package? Yeah, well, why not? Why not do a little concurrent package development? So we're going to go over here, and we're going to go into our term colors, which I don't even remember where it is. Where is it? 21. So, nope. Where is term colors? I mean, if my Go work has that for me, I just can't remember it. It's 19. Okay, so we're going to go into 19. I'm going to go to 19 here. Whoopsie. CD into 19. And we're going to go into term colors. We're like, I don't like typing because I'm lazy. And what the hell? Oh, I CD'd into the wrong thing on accident. I am so sorry. All right, so here we go. Term colors. .go. It's like, God, I want an alias. Why the hell can't I have an alias? Now, you can actually make aliases like this. Actually, what's the pointer alias where you want something that points to the same position in memory without making a new one? There's actually a really cool trick to do that, and I can't remember it. I think it's a pointer. Golang aliases for constants. There's a way to do it so that it doesn't occupy more memory, and I can't remember it offhand. I mean, we don't need this. It's a small. It's like 1 byte. but I kind of want to look it up. Or something like y package const equals 3, var equals 3. It's kind of a cool trick, and I can't remember offhand now, but I remember that it exists. Does anybody know it? I'm pretty sure it's a pointer, but it's not commonplace to do it, so probably not a good idea. It's probably a better idea to point to the constant, and that'll get inlined. So let's do that. Let's say r equals red. Constant compile time. It's also inlined, yeah. So we're good. Constant. I mean, if you don't want to do all this, by the way, hey, how are you? Let's do this. Let's do the other version of this where it was just this, right? We can get rid of all these. In fact, we can un-CMT all of that, and that'll delete that all for me. CMT is a generic thing that just removes the first white space, non-white space thing in my thing. Use CMT so I can kind of cheat. I use this Unix filter that I just used. Yes, that's exactly what we're doing. You can go check the boost. We're teaching Go programming right now. We've been doing it for 4 weeks now. So we can actually say B for black. Should we say B for black or BL for blue? I think black should just be black. I don't know. What do you think? K is black? All right. I'm game. We can do K for black. CMYK. RGB. K is black. Oh, K is actually black. I did not know that. I feel informed. So we'll say G equals green. This stuff might look hairy, but it's actually going to be all inlined by the compiler, and it is be the most efficient possible. So just know that. And B we'll say is blue. Magenta equals magenta. Cyan equals C. White, it doesn't have any, which is weird. Reset. I've used to make reset X actually. I've been making reset X in my world. And clear. We'll leave clear as clear RCL. These are like really special, so let's leave them the way they are. So look at that. Look at all those pretty constants, right? Now that's not been committed to anything. We are still sort of debugging this. If you want to get crazy, you can actually update your unit tests to use all of those. I mean, you could very easily just copy those unit tests you already have. I mean, you could even do worse than that. You could do this. You can take the exact same test. Oh, check this out. Check this out. Okay, so if you're using VI and you're using the Go Vim tool, you can use YAF. YAF. It says yank the outer function. It yanks the entire thing. If you do YIF, it yanks the inner function, all the stuff inside of the func. And that's it's a specific thing. So you can actually duplicate the entire function, including whitespace, and grab the whole thing. So like Primagian uses DAP all the time. Primagian taught me DAP actually. Even though I laugh at him for using Control-C instead of Escape, I'm super grateful for that because I learned DAP. DAP only grabs a paragraph though, and that would miss like the spaces and stuff. YAF. Yep, it's called YAF. Yank outer function or yank whatever. There's also YIF, which grabs the inner part of a function. Let me show you. So YIF grabs only this stuff inside of the function. So if you wanted to dump the body of a function inside of another function, you could do that, right? So there's YIF and YAF. Those are added by the Go Vim plugin. So very, very useful. Anyway, so we've got example black, but this is what I want to show you. So it's the same thing. We still want to. I don't know why this is example black. This shouldn't be example black. This should be example just colors or something. But I don't know why. I think it's that. But anyway, if we wanted to make it shortcut, right? Shortcuts or something. It has to be lowercase because it's going to get an. And then what you can do is you can actually change these, right? So you can change this to K, you can change this to R, We change the resets. We're going to change reset to X's. Oopsie. Change word. Change CW to X. And then we're going to do them all. All right, so those are all X. Let's change the green to G. We're going to do D. Word. Yeah. DW. 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 And consider yif yaf and their Go languages. Yeah, and we can say so we can actually run this test now, and it should work. Go test DW40. Hey, look, I passed. So I was able to create a test very quickly for my shortcuts by just duplicating this previous test and giving it an extra extension, which will show up in the documentation as black space shortcuts with a capital S when it appears in our doc. So we're doing concurrent package development here because we use Go Work, and we can now use all of this cool new stuff that we got over here in our Waffles program. So we go back to Waffles, and we've got our CR, our CY, and we can do our build again. We haven't messed with stud in and stud out, so we're going to say, ooh, not enough arguments to CLI prompt. Well, that's good. Let's, we have to have a prompt. Oh, that's right. We need to tell it what we're going to prompt from, remember? Oh, that's cool because now it's testable. You remember how we made prompt testable by passing in the stud in and reader and writer? Remember that when we spent the time to pass that in? Well, guess what? By doing that, we just made this code testable. I love it when that happens. I love it when you do the right thing for all the right reasons, and then later on you get blessed for doing that without even thinking about it. So the reason that it's barking at me is it's like, we don't want to assume stud in, os.studin, right? So I pass stud in, that's where I want to read it from. This means that I can actually test this by passing it to the package. Now, wouldn't it be cool if run took an option to read from? Maybe we should pass this. I think we probably should. os in is an IO.reader. And why would I do that? If I do it this way, I can actually use this exact program with a TCP/IP pipe instead of a standard. I can make an entire server that runs over Telnet just because of this. So I'm passing in the input, and because I did it right the first time, I'm being rewarded now. So then I can do this. I can say, go ahead and do Waffles. I want IO reader. Isn't it an IO reader? Did I not pass it? Oh, wait. So our program has to change now, right? So now our main program has to change because we're passing in a piece of input. So we're going to say os.studin, right? But our tests don't have to pass os.studin. Our tests can pass something else, right? Our tests can pass in a string reader, and we can actually simulate the interaction. So this is some good shit. Look at that. Hello. Okay, it worked. It worked, and it did the colors and everything, so we don't have to get crazy with the colors. We can just keep it like this. And let's put a space here, actually. Do you like waffles? Now, there's a couple ways of doing this. We could do it like this, or we could actually print out the stuff and then put the prompt sort of generically after each request, so we're not passing the words every time. That might be the thing to do. Right? In which case, maybe it's good to have, like, I don't know, maybe it's good to have a private prompt. Maybe we really don't need it, but we could use a private prompt, or we could use this prompt. So let's do that. Let's say we have this private prompt. We say, do you like waffles? So we could say fmt print. Let's say println. Let's make it so that the answers are always on the line after that. How about that? So, I mean, we're just spitballing here. So let's say that we're going to do that. We're going to say, I want that. And then the prompt is going to be very basic. So now, instead of the prompt being all fancy, we can make the prompt like special. We can make it black or green. How about magenta? Let's make it magenta. let's make the prompt a magenta thing, and then it has that, and see what happens. Let's try that. Let's rebuild that. Do you like waffles? Yes, I like waffles. I mean, that kind of looks cool, don't you think? We got like the different colors are popping in, and stuff. So do you like waffles? And then what? Okay, well, so if then we have a question. So if, I mean, what's the video? We can go watch the video again, right? So the song is, do you like waffles? Yes, I like waffles. Do you like pancakes? Yes, I like pancakes, right? So, but what happens if they don't say the right thing? All right, what if they don't see the right thing? So how are we going to check for this? Now, this is where we get to have some fun. And we could go all the way up to craziness and have AI interact with this thing. Or we could set up some regular expressions, which are appropriate answers. All right, so let me tell you what I mean. So right here we have, do you like waffles, right? And we're going to put the whole thing in a loop. So do you like waffles? Yes, I like waffles, right? So if they answer, yes, I like waffles, should they have to type, yes, I like waffles, or should they type yes? Or we want to have them allow them to type both. Okay, so let's start with the actual video. And we can say, okay, so we have the response. So let's say response equals, right? That's the first time, so we'll use a waffle operator. And we'll say this, let's say response. Let's actually just print the response for now. In fact, we're going to debug it, so let's log it. Anytime you're doing debugging, the log package is your friend, because it's guaranteed to not interfere with anything else, and you can grep for it really easily and delete it from your code later, unlike FMT, because you might have actual FMT prints out there. So having the distinction between logging and FMT, the log and FMT package is a really good idea when you're doing debugging. I see people fail to do this all the time. It's very annoying. So we're going to go run waffles and say, do you like waffles? Yes, I like waffles. Uh-oh, we didn't get recompiled. We had a compile problem. Assignment mismatch, one variable, but clump lost two variables. Oh, did I get rid of it again? I don't understand. Wait. Oh, it must be the error. Yeah. And then we're going to have if error equals main, which I have as a macro. Log pronoun error. Yeah, it's individual error checking. Yeah, we might have to put that in our own function, because that's going to be annoying as hell. Yeah, it's going to be really annoying. By default, if I recall, yes, it does, which is also very useful. You can also change it, right? You can make it print wherever you want. It's extremely useful. I think the log package is one of the least appreciated packages out there. It's a very good workhorse. Yes, I like waffles. Yes, I like waffles. So there's our notification. Notice how it's still colored that color. So we do have kind of a bug here, don't we? Even though it was printed to std output, we still have a problem here. So let's fix that problem by adding something. So we have a yellow starting here, but after we get the response, we should probably, clean this up by fmd println. We're going to just do just a print, not a println, and we're going to do a c.x, and that's going to be that invisible reset that's going to clean up the color. And if that one thing is going to clean our colors up. So yes, and then you see that the actual output is correct, right? In fact, if you don't have a colored prompt, you'll see that last color that you print will bleed and take over everything you type from that point on, because it's stateful. So every time the terminal sees a state change, specifically color in this case, it just keeps doing it. So there we go. We got, do you like waffles? Now, the thing that's kind of annoying is all this code right here. Yeah, I mean, we're going to be typing that a lot, right? So no, let's make that into a private function prompt. It's a local private function. We know it's going to be the same thing every time. And the only thing it's going to print, it's going to return is the value, right? So we're going to have it return a string. It's very hard coded, very private. We don't need to really put anything on there. It's just going to save us time. And then you could say prompt, every time here you could just say prompt. You could say response equals prompt, and we can have that hard coded. Okay, so that's just a little bit of factoring, localized factoring to keep our code clean. And let's run that. So, do you like waffles? Uh-oh, we got some errors there. There's no in. Damn. Okay. Well, we got to pass in, I guess. I didn't want to do that, but oh well. Yep. Prompt in. I mean, that's fine. Missing return. That's right. It's exactly right. We're missing return. FMT print the X and return RESP. If actually, here's something interesting. We can just log it and we can return a blank. So there's lots of little stuff here that would really be annoying if we had to repeat it. So we'll do that. Do you like waffles? Yes. And everything works as, so that was a little bit of regression testing, making sure we didn't break anything. But look at how much simpler it is now, right? If you want to, you can put docs up here, but you don't need to. And so, yeah. So, okay. So now comes the check. So is the response equal to yes? And we're going to start with the simplest form, but there's obviously a million problems with this, right? And you can probably immediately think of problems with this, but okay, then what? How about if the response doesn't equal yes? If the response doesn't equal yes, then return or end. How about that? End. We'll call end. And we don't even know what end is, but we'll say end. String. We'll just say end. Say fmt dot println the end. I don't know. We're just gonna do something simple like that. So if the response equals yes, then end. Does not equal yes, right? Now there's obviously problems with this, and I'm deliberately making the problems so that you can understand regex and a bunch of other things. So do you like waffles? No. The end. Okay. Do you like waffles? Yes. Oh, okay. Well, it still kept going, right? What is it going to do next? Well, I don't know. Let's say vmt print. Let's do a log here. Log println would continue. Okay, so let's do that now. So, do you like waffles? Yes. Okay, it would continue. Do you like waffles? No. The end. Uh-oh, we have a problem, Houston. So, the end did not end, did it? So we need to use another program. This is you'd have to learn about this. It's called os.exit. And we're going to exit with a 1. You remember back in Bash days when we talked about 0 or 1, 0 being success and 1 being failure in Bash? Well, this is going to exit the program itself. That means that you normally would not want to do this unless you know it's usually a very bad idea to completely kill the program, right? But in this case, we don't want the program to continue. We want that to be the final thing that happens, and go from there. So yeah, no, and like the end, right? -1, people usually instead of back. -1 is also good, but a 1 through 255 is available for having a negative return state that has an error condition of some kind. Yeah. People don't use -1 very much these days. It's usually 1. People definitely do use it though. I've seen it. There's really no standard there. So anything non-zero. 0 is success in Bash, in terms of return code. So, going to use the negative for some errors. Yeah, it is a convention. Yeah. So here we go. So we have, do you like waffles? Yes or no? And we continue. So this is all good, right? But we obviously have a problem here. What is our problem? Yes, I like, how about this? How about they type capital yes? What? I typed yes. Hence the problem. Now, I'm going to fix this a number of different ways as we're going, but we're ultimately going to end up using something called a regular expression. So the other way to do this, I mean, this gets really laborious, right? You say if it does not equal yes, or that's an or operator, response does not equal yes, or response does not equal yes. You see what I'm saying? It gets pretty annoying, right? Right, Henrik, that's another really great option, right? So yes, good. I'm glad you guys noticed that one. So there's a number of ways to do this, and I'm glad that we're talking about that way, because that is, I believe that's not the perfect way, but it's actually a very lot better than what we have here, right? So then we can do strings dot to lower respect or response yes, and now we're guaranteed that it's always going to be yes, right? And we can run that, and we get, do you like waffles? Yes. All right, and it would continue. What if they do this? What if they do yes with an exclamation point on it? What? So I mean, there's lots of things you can do here. One of them is instead of saying to lower, this is all in the string stuff. Instead of saying does not equal exactly yes, you can say it begins with yes. You can say strings. We're going to do all of these things, okay? They don't deserve waffles. Okay, strings, you say has prefix, okay? Has prefix yes. So now this is a function. And you can go look it up. Actually, if you just do K here, it'll show you. It tests whether the S begins with the prefix, okay? And you can write Alexa for English. You absolutely could. I'm kind of going there. So, when you're writing interactive things, so now we have yes, yeah. Now we have the, wait, what? Wait, we failed. We failed somehow. Why did we fail? It should have worked. Oh, I forgot to negate it. Whoopsie. So yeah, if it's not yes, so we got to put an exclamation point there. I'm writing Alexa for English. A fuzzy search. Yeah, so if it's not yes, then end. All right, so we put that exclamation point to turn it off. Yes. Would continue. How about this? Yes, exclamation point. Okay, would continue. Ooh, cool. What if they put a space, and they type yes? Damn. Is it working? It is working. Why is it working, by the way? Because we already did the right thing. Tell me why that's working. I'll tell you why. I just remembered. It's because we actually did the right thing in our CLI package way back when. Way back when we did our CLI package, which is in 19, right? When we wrote our prompt package, we did the right thing. We did the right thing. What do? We trimmed our input. Readline. We made a readline function, and we did a strings.trim space. What does trim space do? It chops off the white space at the beginning, spaces, tabs, whatever, and it chops off the space at the end. So we already covered that scenario. Yay on us. Good on us, because we already covered that. So we don't care. It actually works. So if somebody tries to get crazy and try to break it, they can do that, right? I mean, if you want to get really crazy, you could say, well, really, we don't care as long as it begins with Y. I mean, because like, what if they do this? What if they say, do they like waffles? Yeah, I love waffles. At the end, what the hell? I can't say yeah. I want to say yeah. I want it to be colloquial. I want it to be like nice and all. Well, I can go back and say, okay, if it begins with Y at all, it counts. And I've seen this in code. So it's like, do I like waffles? Yes, I do. Would continue. Do I like waffles? Why? Do I like waffles? C. Damn. Well, now I have to do something. Approximate stream action. Oh God, this is gonna go. We're opening a whole thing here, right? So, and this is the thing that's really crazy about this is you can make an entire thing that has every form of affirmative possible. And it's kind of fun to do, but we're not going to get too crazy. But we are going to get a little bit crazier. Predefined answers to kick them out. Yes. If you say yours, no. Oh, that's a good point. That would not be a true. That would not be a good thing, right? So, another thing you can do is you can also tell them what their potential answers are. You could say, like, you could put up here, you could say, and by the way, this is typically the thing is you do y/n. You've seen this before, right? So typically people will capitalize the default and they will put the other answer, and that's informing them that here is your answers, right? To determine the result. You totally can do that too. So, do you like waffles? Yes or no? And this is for most shell scripts. This is usually going to be what you're going to see. It's very precise. It's very specific. It's it has all of that, but we want to have a little bit more fun here. So we're going to keep this around just for fun, but we're going to use a regular expression. Now we've talked about regular expressions in Bash, but we're revisiting it again. Regular expressions are a massive, massive topic that are very well covered by Go. So what we can do here is we can say, instead of all of this, we can say, okay, I would really love if I had any of the following. Now you can actually do an independent string subsearch for this, or you can make a regular expression. So the way to do a regular expression is almost always to do must compile. So we're going to say, we're going to make a var, it has to be a var, and we're going to say, I want my expression to be called yes, we'll say, okay? And I'm just putting it in all caps for no particular reason. Better make a multiple choice. We are, actually. And so then we say var equals yes, and we say regex, I think it's regexp dot must compile. Must means whenever you see must and go, it's a convention you should really get acquainted with. Whenever you see must and go, that means that if this is not true, if this function does not work, it will panic. Okay? And the reason you like it is because it removes handling the error. So in this case, we don't want our code to compile if there's anything wrong at all with the argument I'm about to pass. We don't even want it to compile, right? And we want it to die when it first runs. Actually, it will compile. It will just die on its first run without even running. So over-engineering at its finest? Hell yeah. Hell yeah. I mean, when else are we going to have an opportunity to over-engineer? So we can make a regular expression called yes, and you could say, and I actually like to use backticks for this, but you can use double quotes if you wish. And then I'm going to say it must compile. Well, what should we compile here? Okay, well, we know we want yes, right? We know we want or, yeah, or what? Or affirmative, or whatever, right? So by doing this, then we put this so we have any of these are options, and now we put we talked about this a little bit, but you just kind of have to learn it. That means at the beginning of the thing. So if it begins with yes, yeah, or affirmative, or yep, sure, yep, sure, you know it. I mean, you can put it all there, right? Okay, colon C, all of them. Now, what's really crazy is all of these have a Y in the front. So if you want to get really nuts, you can do this. You can do yep, yeah, and ep. So there you go. Save a little space there. So now yes, yeah, and yep are all good. Yeah, you can have da. You can have, I mean, talking about over-engineering, there you go. All right, there's your must compile. So now all of those mean yes, right? And assuming that compiles, then down here, instead of just doing this, you can say, if it does not match, if it does not yes match, then end. That's it. Then it's false. Yes. So if it's not that, then boom, we're done. So let's see if that compiles. I don't even know. We're going to find out. Nope. Declared but not used. Not enough arguments and call to yes.match. All right. Well, I don't remember what I did wrong here. Oh, right. Yes.match. The response, of course. And so then it says, hey, is it going to do its thing? Let's see. Oh, cannot use response as type string. So this is a really common problem. So there's two types of like wordy things: strings, which have double quotes, remember, and byte slices. A byte slice is different than a string. They're treated differently, and it's treated more as binary data. For all you care about at this point is that you can always cast a byte slice into a string. Sometimes it doesn't come out right, but you can do that. You can always cast a string to a byte slice. They're kind of, but you'll notice that that actually, if you can either do that, we could either, so there's this thing here. You could do this, right? You could say string, or that will work. We're not going to keep this, but I want to show you that this will actually work. What? I type byte slice and argument yes. Byte and argument to yes. Oh, wait. I'm sorry. We did the wrong cast. We need to cast it to a byte slice. So we can take a string and turn it into a byte slice. UTF-8. Yeah, Unicode. It's Unicode. Yeah. So, and it's kind of a long answer there. I would really love to get into it. Rob Pike, who created Go, was one of the people who created Unicode. So yeah, everything's UTF-8. What's really, really crazy, it's going to melt your noodle, is that any iteration over strings is Unicode aware automatically. So if it's 3 bytes, it'll skip 3 bytes. And you have to explicitly cast it to a byte slice to tell it you want specific bytes at a time. That's built into Go at the lowest level. It's really amazing. It's really, really amazing. But in this particular case, that's probably not the optimal thing to do. There happens to be another option called match string, which is kind of friendlier, and that will use the string form as input with the old runes and 32s. Yep, it does. It's so cool. It will yield runes. Yes. And they're not always, yeah. JavaScript GTA 16? I did not know that. I did not know that. Maybe I knew that at one point. I did not remember it. I'm glad you told me because I don't want to use it. Yep. We continue. How about this? Da. Okay. How about this? How about yeah? How about this? How about yeah, baby? Yep. We still continue. How about affirmative? Affirmative. Now, this is the first case where it kind of makes sense to probably not write a test case that uses examples. This is one of the times when writing an example test might not be the best solution, because we have sort of a fuzzing situation here where we have a lot of possibilities that we need to check. It's not really fuzzing, but meaning we've got a lot of things that we need to check. Yesterday? No. Yeah, it actually would take yesterday. Yep, it would. Yesterday. Do you not want it to? If you don't want it to, you can lock it down by saying $. Yep, if you put $, then it will only be one of those. But then you can't say yeah baby anymore. If you say yeah baby, it'll be like, okay. But you can say yeah will work. So that's $. $. Locks it to the end. We've talked about regular expressions before, and there's really no way that we can. I mean, just a little bit of them at a time is probably the best way to do it. But most people can probably make sense of that as a regular expression. And by the way, we lost our case insensitivity though, didn't we? Yeah, watch this. If I do it here and I say yes, what happens? Oh, we lost it. So how do you add that back? Any of our fancy people know how to do that? Anybody know offhand how to do it in the regex? There is no /i on the end. This is a trick question for some of our more veterans. So I'm having kind of fun with this one. There may or may not be something you can send to your regular expression engine that will disable case sensitive matching. That's inline. Oh, you got it. Das Wolf got it. Das Wolf got it. So if you, and it can be anywhere. If you add this, it's the same as /I in a regular expression. It disables case sensitive matching from that point on. In fact, you have to turn it back on. It's kind of stateful, like our color codes in ASCII. As soon as it's encountered in the regex, everything from that point on will be case insensitive. So by doing that, you know, you can say yes, and now it would continue. Okay, so that's important because I mean, people that have learned regex have learned to do /I, and they don't know how to. They get tripped up when they try to do case insensitive matching. They don't know how to do that. So that's how you do it. There's other things that you can pass into regex to change whether line return is considered white space or not, and things like that. Regular expressions are extremely powerful and usually overkill. Somebody used the word over-engineering today, and they're right. We obviously don't need this. PCRE, these are all PCRE supported by default. These are PCRE. So if you know they're Perl compatible regular expressions, people talk bad about Perl all the time, but one of the things Perl gave us was a universal regular expression notation. Thank God. And it still continues to do that for us. And there's a bunch of classes and subsets and thing, but for now you can use this thing. A long time ago, I actually used the regex as my title because I was, CFO and I had CEO and all that. And I was like all the letters in the middle, and I actually used it as on my card, on my business card, because people knew it. They were like, what the hell is this? I'm like, this is all the titles that I fill, running my own business, including janitor. It's kind of cool. If you want to be cool, you can set your title to be a regex, because I mean, how does one title possibly fit everything you do, particularly as a micro business entrepreneur? So I enjoyed that. That was fun. I'm a huge regex fan, but they have limitations, and I want you to be sure you understand something. Regexes come at a cost. Okay, so I actually caught this in I'm an early guy doing peer review on our code. So my team member, who hasn't done as much coding as me, but he's done a lot of amazing things. I'm peer reviewing his code, and he actually let me tell you something. Regex is very expensive to run. I mean, we're talking nanoseconds for most people, but you multiply that times millions of hits, and a regular substring match is almost always going to be better, right? And this is one of those opportunities where people who are cool will use regex when it shouldn't be used, and but it works. I'm like, yeah, but it's like really crazy and expensive, and it's unnecessary. I wrote a regex for an entire Etsy host. Of course you did. But let me ask you something. Compile on regex. Actually, regexes were invented originally, partially, to write compilers, using Lex and Yak and stuff. If you go to college to learn computer science, you'll learn regex as a part of learning how to write a parser. If they're still in the whole Lex and Yak vein of parsers, which is really dated, but whatever. So let me ask you a question. What's the difference between this? This is very important. What's the difference between this and this? Code still works, right? What's the difference? Since code is exactly the same. The code is exactly the same. It's for lowercase or uppercase. No, all I did is move the line. We changed the scope. Okay, so when inside run, it doesn't try until it calls the function. Right. Now, something you need to know about regex expressions, and this is super duper important, and I love that Go is explicit about this. When you use regular expressions in Python or Perl or any interpreted language, JavaScript, it's not really clear what's going on behind the scenes. So let me tell you something about regular expressions. Any regular expression on planet Earth, whether it's in Bash or in Go or in C, has to be compiled. They have to be compiled. When you're running in an interpreted language, almost always it compiles the regex and then applies it every time. That is why interpreted languages are so slow in comparison to languages that have the ability to pre-compile the regular expression. Okay, so I'm telling you this story because I actually found this in production code, or with test developer code, last week. They had a REST API that had a regular expression match, and it was checking it, and it was compiling the regular expression for every request of the API. Instead of this. So instead of, you know exactly what I'm talking about. See, Computer Nerd gets it. So instead of compiling the regular expression once when the program started, it would recompile the regular expression every time there was a REST request. That was hard to say. A REST request for that function. Yeah. So think about that for a second. This is Go. So think about that for a second. So literally, potentially, I mean, let's say we get 1,000 hits a second or 1,000 hits a minute or something. That's 1,000 regular expression compiles that didn't have to happen. And let me tell you, compiling a regular expression is not a lightweight operation. It's not. In fact, it's potentially DDoSing. You can actually manipulate a regular expression to cause it to infinitely compile, and you can take down systems with a regular expression if it's been written incorrectly. So be very careful when you pick a regex. The moral of the story when we talk about regex is don't use them. Use a substring. 9 times out of 10, you can simplify your interaction, and you can use a substring and you're just fine. Now you're just comparing bytes. You're comparing like maybe 16 ones and zeros like immediately. And it's like infinitely faster to do that. If for some reason you want to simulate, a human-friendly interface like we're doing here, and you have the cycles and you can do it, at least don't put the compiles in the functions. Make sure they're at the top, and they know they. For that reason, by the way, I usually put all of my regexes at the top. So I like constants. I will usually do this. I'll usually group all of my regexes in a file of their own. Or at the top, so that I know that they're all getting compiled, and I just go pull them out. Plus, I mean, if you're doing any kind of language writing and you have like multi-language support, you're already combining everything that's got words in it in the same place, and that's a good place to put your regexes. You had to put 2 problems. Yeah, that's a pretty common. Yep. So anyway, I just want to put that out there as you're entering into this state. So you didn't know that Do You Like Waffles? You were going to get a regex lesson, did you? But it's a big thing, and international language support is an important thing too. So up to now, we talked about this in our Greet program. We kind of got stuck on this, but we're using English here. We're using strings here. So in some programs, they would replace Do You Like Waffles with a constant, and that constant would be in a file that's only loaded into programs that are compiling for English. And all of the strings, all of the English language stuff would be replaced with strings. And those would all be pulled out into a separate file. So I know that we're kind of going over the top here. That's not something like a 12-year-old would care about. But this is kind of a larger scope than that. All right, so then we would continue. All right, so how far are we in our little thing here? Because I don't want to go too much farther. All right, we spent another hour. It's time for us to take a break. When we come back, we're going to do some iteration. We're going to do some looping. And we're going to break out of the loop. We're going to use some breaks and some other stuff like that you haven't seen before. And we'll see how we go from there. So here you go. YouTube, take a break. Care about initialization. I think a bilingual one would probably care about initialization. I don't think it's a non thing. It's definitely an issue. So it's generally a bad idea to put strings in code. You should probably pull those in from someplace else. And independent. I mean, there's lots of strategies for that, but yeah. Anyway, and we're back. All right, so we have like 90 minutes left or so, maybe less. We'll see how much we have to do. What do we have left? We have challenges. We're doing waffles. We're not doing Bridge Keeper today, so this is gonna be the last one, whether or not we finish early or not. You guys can go have fun on your Sunday or Saturday or whatever. Bridge Keeper is actually a fun project, but it's gonna take a little bit longer to do. And we're gonna watch the full Monty Python skit. That's gonna be next. That'll be next week. These other projects are pretty fast. So let's go do that. So we have a program that says, "Do you like waffles?" Check if Parrot is live. Yeah. Do you like waffles? Yes, we like waffles. Right? Do you like... So then what do we do? Do you like pancakes, right? Now, obviously, we've already factored out the prompt, yeah? Now, there's a million ways you could have done this. You could have, and I'm not telling you how to do it. You could have done it by making a prompt that takes a name every time, but we already factored that out. So we'll just put this down here and say yes, okay? Okay, I want you to see something here. This particular type of flow is very idiomatic for Go. What does idiomatic mean? Let's just remind you. Idiomatic. Idiomatic. Idiom, also called idiomaticity or idiomaticity, is a syntactical, grammatical, or structural form peculiar to a language. Idiom is the realized structure of a language as opposed to possible but unrealized structures. So it's basically the way to do it. So an idiom is a standard way to do things. So let me give you an example. So in Python, it's very common to have if-else statements, right? In Idiomatic Go, else is frowned upon. It's not used. In fact, Python doesn't even have a switch statement. I think it finally added it in 3.6. But Go has got a switch statement, which, we did a little bit of that last week. And so when I say something is idiomatic, what I mean is that it has, it's preferred when you are, using it. So we're going to call it idiomatic flow in Go programs. Now, of course, idioms are influenced by lots of things. That's not good. I am failing right now. Don't mind me. All right, so idiomatic go flow. So how do I say this? Everything on the left. This is a very simple way to say this. This is very idiomatic Go, and you'll see people that violate this all the time. But generally, if you're going to code for the Go project itself or something, the idea is, and blue sky. So what is blue sky? So blue sky, blue sky is a term meaning that, if everything goes well, like the green thread, the thing that's going to always be true and that has exceptions to it. So you have the main flow, the main thread, the main whatever, and then you have all of the exceptions to that are not. That is very, very common. And the goal of this is so that when someone is looking at the code, that they scan the stuff farthest to the left and they can quickly get an idea of what's going on. And this is, by the way, the reason that exceptions have been turned down as proposals to the language forever, because they completely defeat this idiom. If you have a huge bit of code, and first of all, if you have an exceptional block, you almost always you're forced to indent, right? So how many times are you going to indent for each different exception? Pretty soon you end up like 15 levels of indent. By the way, the more nested and the more indents you have in your code, the worse of a program you are. Because you shouldn't. You should only have 1 or 2 or 3 levels of indent, period. If you have more than that, something is wrong. You're either doing generated code or you're not factoring properly. And I mean, that's a general rule. But so the idiom in Go that I just want to get across here is that the blue sky is to the left. So, and here's an example of that. Instead of saying if it's to match the string else and do else and then have another thing here and then have potentially another thing here, you cancel the flow by exiting out of the flow, either by returning or in this case calling end, right? And therefore your exceptional cases are the things that are indented. And that's really the main thing. your exceptions are indented and they're not left justified. Your main stuff is to the left. And so when you're making, this is a big thing. I mean, one of the reasons we're doing this is because designing the code, the flow of the code is very important. And this is the part of where code becomes kind of an artistic craft, because you are creating, you're writing stuff that's easy to digest. And I mean, you know this. So you could go look in code that's been really well written. And I'm like, oh my God, this is a work of art, because it's so easy to comprehend. It's got such clean flow in it, and just very, very understandable. And believe me, when you read code that does not do that, you'll know. So, do you like waffles, right? Do you like waffles? No. Okay, so we can say, do you like pancakes? Cakes. Do you like pancakes? Yes. And we can do our prompt again, right? And we could say this. We can grab that whole thing, yank that, and put that down here. This is going to have an error in it, though. Why? Why would it have an error in it? Tell me. Catch the bug. I do this sometimes. Show me my bug. Why is this broken? Spend some time looking at this code and see if you can find the bug. There's a deliberate bug in there. What happened? No, because I did it wrong. I did it wrong on purpose because I want them to see the bug. I did something very, very typical. I was like, oh, hey, I can just reuse this code. Copy and paste. DAP P. And I pasted it. And I pasted a bug. How did I paste a bug? I want you to see this one. I really want you to see this one. You got it, Lumber. Why? Did everybody else see it? What's that called, by the way? Another little test. What's the name of that operator? What's the name? What's the actual name of that operator? I suppose it's an informal name, but what's the name of it? So it's saying the colon thing. What is the name? The walrus operator. Okay, so the walrus operator up here, which does what, by the way? Another review question. What does a walrus operator do versus a regular equal sign? Yeah, shadowing, all kinds of stuff, right? So a walrus operator is shorthand for what? Literally, I could have done this, right? var RESP string, and I could do a response equals prompt like that, right? Declaration. There's some stalwarts who say that that's the only way you should do it, especially if you're going to be using response all the way through the thing. That might be a better way to go. It's a reminder at the beginning of the code, hey, I'm going to be reusing this variable a lot, so get ready, here it comes. Sometimes declaration, even though it might be longhand, it makes more sense. Also, it makes it so that when you cut and paste, it wouldn't have been broken, right? If I had cut and paste that code, it would have been fine. It would have been the same. So occasionally, sometimes you'll get that problem with errors too. Avoid shadowing most of the time. Yeah, shadowing is, especially with errors, especially with error return codes, is super easy to do. So, and by the way, why not this? This is. I'm just going to cut to the chase. Strings, idiomatic strings. We need to talk about zero values. Okay. I'm just going to cram a discussion about zero values in the middle of this other conversation without any rhyme or reason. I apologize, but I'm going to do it because you really need to hear about what they are. Zero values are, so unlike pretty much any language I have ever known, any mainstream language, zero values in Go. So zero values are values that are automatically assigned to Go declared variables. This is actually one of the most controversial things in the Go language. It gets hate all the time. When you declare a variable string, you are also implicitly assigning it the value of an empty string. In other words, this is exactly the same as this. Exactly the same. It's implied. That implicit zero value declaration creates all kinds of amazing ease of use and simplicity. Rust, for example, doesn't let you do that, obviously. C doesn't let you do that. JavaScript and other languages like that do kind of let you use it. Take it the way that is the absolute only way to do it. Depending on where it appears, ping. We'll talk about that. So so what is the zero value for a string? And you can actually look this up. I mean, if you do search for Golang zero values, you can look them all up. And let me just paraphrase it really quickly. I think they're actually summarized here. I mean, there's a million sites that'll tell you what the zero values are. So, okay, so for an integer, it's the number 0. For a floating point, it's 0.0. For a Boolean, it's false. For a string, it's the empty string. For a pointer, it's nil. For an interface, it's nil. For a slice, it's nil. Map, nil. Any other structure is nil. The only time zero values really matter is for, in my opinion, strings, integers, strings and numbers. Strings, numbers, and Booleans. Is the first case does not equal nil. Yeah, I use does not equal nil. Of course, that's what I use. I thought that's what you're asking. I'm sorry, I misunderstood. So now you know what zero values are, right? So, and the idiomatic way to represent a string that has not been initialized is this. You'll see this in code, including my code from before. You'll see that. And that's fine. It's just not idiomatic. The only time you would do that is if you want to set a default value, which is also a very strong idiom. It's very used a lot. So if I wanted to say like no and have that be the default, and then that's very acceptable. It's almost never ever seen to do this, but it's totally possible to do this. This is also possible. A declaration mixed with an old style. That is valid Go code. I've never seen it in the wild. It's very not idiomatic. It's more common to see this. So as a default value, but it may be tempting to do this. This is actually not idiomatic. Here's something else that's not idiomatic. Let's say you have a struct, right? So you could say like name or profile or something, and then you would have like, I don't know, profile like this, right? That is also non-idiomatic, and so if that was a struct, you would not do that. You would probably either do make, or you would just say var name is a profile, and then you would use a zero values for the profile. In other words, use of var for declaration with assume zero values is the preferred method of doing this, and I can prove that. You can go read the Go style guidelines and all that. They'll talk about that. In fact, it was in reading that I discovered that I was doing it wrong for a long time. Not wrong, just in a way that was not idiomatic. So we're going to tell response as a string. So now we've got past our problem down there, and we have our response down here. So we still have a prompt. We can still use prompt just like before. We can reuse the variable because we're throwing out, every time we reuse a variable, what happens, by the way? It doesn't add it to the end. It throws out what was in that variable before and reuses it. And that's when, in case you've ever heard about the Rust Go fight about memory management, you may not know, but you could be a noob coming to Rust, and somebody who doesn't care about your knowledge level will come at you and say, but Go does garbage collection, Rust doesn't. Well, now you know what's going on. When you have strings are immutable in Go, no. I mean, yes and no. That's confusing though. They're not immutable. No. So they are immutable underneath, but if you tell someone that they're going to think they can't change their variable, which you totally can because we just did it. Underneath the hood, yeah, it's reassigning a new thing, a new value to that string, and it's throwing out the other one. That's getting garbage collected. It's just zero downing the rest of it. So that's what I'm trying to get to. So, I mean, this is that conversation I just had briefly is kind of C related. So what happens when you reuse a name? When you reuse identifier, more specifically, RESP, right? So this like stumps the prompt, it's like yes this time, next time it might be no. And the value gets pushed into there. And you can think of it like a hat. You can only put one thing in the hat at the time, and the other thing goes out, right? I don't want to get into the low-level stuff about this, but it's super important that you understand that you can totally do this. You can reuse the same identifier in a block of code, a scope like this, and have it contain something else. And when you put something else into it, unless you explicitly say add this to the end, it's going to throw out what was there, and it's going to put the new thing in it effectively. And the computer nerd and other pedantic people will say that that's actually not what's happening. It's immutable underneath it. You don't care about that. You just care about the new thing that's now referred to by RASP, right? At the highest level, that's what you care about. There is some pretty interesting black magic going on to make that happen. And part of that black magic is something called garbage collection. And this is a good time to talk about garbage collection, because inevitably you'll have a Go versus Rust conversation with somebody. What actually is garbage collection? Garbage collection is a convenience to simplify the language. All major languages do it. Rust doesn't, obviously. C does not do it. The lower the language, the less likely they are to do it. Garbage collection is, we've talked about memory, right? So let's actually speak very specifically about garbage collection right now. So we have this response, yes, goes into causes full stops and delays, depending on how you manage garbage collection. I don't have any diagrams on this. All right, so this is supposed to be a boost, so I don't want to get really low level, but I'm going to use very, very generalized terms, and somebody's going to yell, but I don't care, because you're a beginner and you want to understand this. Garbage collection is how the computer language deals, specifically the runtime of the language, deals with memory utilization. In C, in C, you have to very explicitly deal with assigning memory and using that memory and getting rid of that memory and making sure somebody doesn't write stuff to the memory that goes beyond the boundary, because there's no safeties in C to keep you from doing that. Why? Not because C is a bad language, but because C is a very low level language. C was created to create Unix instead of assembly. That's how low level it was. It's a beautiful, wonderful, amazing language for what it was designed to do. And it gets a bad name all the time because people are using it in bad ways, because it's so powerful and so low level that, yes, you can shoot yourself in the foot. And the higher the level, the language, like Go and Rust and Python and JavaScript, the higher the language, the more safeguards and stuff are in place at the expense of speed and specificity. Garbage collection comes at a cost. But what effective garbage collection is what it does is it says, so let's look at this specific example. Okay. So in this specific example, the first response, let's say they say yes, right? And it comes down here and then they answer again, and a new response is stuffed into the response box, we'll say. What happened to the yes response? Where'd it go? That memory was allocated and everything, right? Well, what happens underneath the covers that you really don't understand and need to respond at this moment. But by the way, if you want to understand this kind of thing, tune in around Christmas time when we do Head for C, and I go through C and relearn it every year, because I have to relearn it every year because I forget. And we can talk about these very, very low level things, and this will help you understand every other language on the planet. This is why everybody should learn C. Everybody, web developers, everybody should learn C in order to understand how computers actually work. But this magic is covered over for you by Go, so when the new response gets put into the RSP identifier and it's pointing to that new piece of memory, that old piece of memory up here, since nothing else is using it, the garbage collector, which happens concurrently, it's like over here, it's constantly asking the question, is this identifier, has it got anything actually that's using it or not? And if it says, no, I don't see anything using it, it just throws it away. And it deletes that memory, and that memory gets freed up. We talked about this with the underlying arrays and what an array and a slice is. Go is extremely elegant in its use of memory management when it comes to slices. Slices and the underlying arrays which bolt down memory. And so these conventions that have been built into the Go language make it very effective to write, make it very highly performant, and make it a little bit bigger. Yeah, because the runtime to do that garbage collection has to run, anytime it has to be built into every Go program that you have. Every single time you write a program, you get all the code that you wrote in your program, but you also get the bonus of a runtime. And the runtime that gets added into your code is what allows your code to run. And that's what a language is. And Rust has one. Rust's runtimes is really wicked small. In a C, your runtime is virtually non-existent because you would have to write your own runtime. That's how low level C is. But other languages that have these extras things built into them, Rust or Go, they have a runtime. CLang has a runtime. LLVM has a runtime. So the more powerful the language, the simpler the syntax usually, and the more powerful the language in terms of like writing something quickly, usually the more magic it's doing, and that magic is in the runtime, and that creates extra space for every binary that gets created from the language. So that is why a Go binary, a hello world binary, is like 12 megabytes or whatever the fuck. Unless you trim it down. It's also got a bunch of debugging information in there and all this stuff. You can actually make it a lot smaller if you want to. Why do you care about the size of your binaries? And this is one of the things that people yell at me all the time for yelling about Rust. But Rust is the absolute perfect language for things like WebAssembly, which have to be served up really quickly. The size of the file, the final file for the program, really matters in those cases. Garbage collection can ruin your day if you're writing a very, very high performing game programmer. The reason that there's no high performance games written in Go, and there never will be, is because of garbage collection. Python does garbage collection. People love it at that level. Do they love garbage collection in your game? No. When you're talking about, like a 60 ping versus a 100 ping, like ruining somebody's day, this is why games are still to this day written in other languages. Yeah, Java's got problems too, though. But if you talk about, there's a lot of C++ programs. Yeah, there's trade-offs all the way. But most high-performance first-person shooter games are written in C++ for this reason. There was, for a time, probably 2 years ago, there was a lot of, when it does GC, it totally does. Minecraft stutters when it does garbage collection all the time. Yeah, it's like one of its biggest annoyances. But a C++ version to be made for Windows 10, absolutely. And that's exactly my point. So picking the language is really the reason. And garbage collection itself gets a really bad name. If you're talking to somebody and they want to flex for you, they'll say, yeah, garbage collection is shit, blah, 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 blah. It's usually because they're coming from it as they want like first-person shooter level of performance out of their applications. So if you're like a Bitcoin miner, or you're like writing like dynamic live streams, or video parsers, or you're writing things that even a minimal amount of stutter to do that garbage collection, which is usually concurrent, it doesn't affect the flow. But even so, they love to go off on how bad garbage collection. But our world wouldn't exist without garbage collection, because it makes code much easier to write, much faster to write, and much easier to debug and sustain it. And that's why people write Go for cloud native. That's why the entire cloud native world, Kubernetes, Docker, I could go on for days, is all written in Go because it's so easy to write. And the garbage collection doesn't impact the performance of the things that are being used in the cloud native world. So this is why it exists. It's not a bad thing. A garbage collection is a godsend. It's what makes it able for you to write code quickly. It's what makes Python one of the number one preferred languages on the planet, because it's so simple. Because it does have built-in garbage collection. Garbage collection is not bad. So stop getting on the hate train against garbage collection when you don't even know why it's being used and what it's used for. Garbage collection in your first-person shooter game, probably a bad idea. Maybe C++ for that. Maybe Rust. They tried it in Rust. And then the people that said they were going to write games in Rust said, nope, psych. We're not doing that. We're going to do it in C++, because there's so many tools to do it in C++ already. So, yeah, a garbage collection itself has come a long way. And pick microcontroller driver, a respirator. Yeah, driving a respirator, or just do a word guessing game. Yeah, that's a good point. Yeah, if you're doing microcontroller code, you don't have the size for a runtime at all. And that kind of code needs to be written in C or even assembly, for God's sake. I mean, I remember military contractors, C was too big. And they would write their code in assembly. Certain pieces of their code they had to write in assembly. They literally didn't have enough memory in some of the devices that they were writing missiles and stuff that they were coding for. And so, it's the right language for the job. My one request, this has been something of a rant, and I acknowledge that, but my one request to the world out there listening to this is, before you jump on the hate train, understand what you're talking about. Because Rust people in particular love to hate on any other language for having garbage collection and being bloated. But that is for a specific reason. It was designed that way on purpose and to compete with the other languages in the scope, such as Python and Java and to some extent C. But, do I think Rust is a better language for WebAssembly? Hell yeah. Why? Because WebAssembly has to be downloaded. And every reduction writing Rust is like ripping my fingernails out because it's so horrible. It's so ugly and so bad. And it takes forever to compile. People don't talk about that. Garbage collected languages also compile much more quickly than languages that don't. It takes you forever to compile a Rust language program. The stuff that's been generated at Google, if they rewrote that in Rust, they'd be waiting weeks for that software to compile because that's how bad Rust is at compiling. So garbage collection can sometimes generate security risks if it's not being freed properly. But generally speaking, garbage collection keeps you safer because you don't have to worry about deallocating memory or not allocating enough memory and things like that. So, yeah. Longer than you want, perhaps. Yeah, that's true. With garbage collection, if somebody was going to steal the memory, they're going to go spy on the memory of the program. You may think that that password that you released way back when is no longer there, and you're safe. And if somebody actually inspects the memory, there's ways to do that. If they actually inspect the memory, but you might realize that that token or that password is still in memory because garbage collection screwed you up. And so in that sense, garbage collection can be less safe for programs that don't know how to free memory explicitly. And you just, that's you just need to be aware of that. But the people who write software at that level know these things. And you can definitely explicitly force GC. There's millions of ways. You can do it in the code itself, right? You don't even have to do some extra special thing. You can actually do things to make sure that the number of references to that code are gone. You should generally not have to think about it. But if you are doing very, very secure, if you're writing the next SSH, then yeah, you probably want to be very, very meticulously aware of how memory is managed. And by the way, in those cases, people would write that in C. Almost always. They would write that in C or Rust, frankly. I mean, that level of application, because there's not that much code to compile in one time. Writing a tool like GPG or SSH without introducing a ton of new bugs, which are also a security flaw, are most likely going to lead to better code. And I am on board with that, with the dream of Rust. Unfortunately, they haven't fulfilled that yet. They keep talking about it, but I haven't seen anything. So we'll see. Okay, back to our pancakes. You can mess even writing in C. Yeah. If you don't know these things, you shouldn't be writing in C. That's why you should write in C. You should write really bad C so you can understand. You can't even have a conversation about these things until you understand why is Rust so much better than C. If you've never written in C, you don't even know why. You don't. So Node.js versus Go. That's an obvious one. Node.js is the devil. I won't use it for anything. Yeah. I don't really want to go there. It'll just sound like I'm hating on it. Node.js is a disaster. The creator even said so, and not just to get you to use this new thing. Go watch 10 things I hate about Node, and then go read about every NPM worm that happened, the biggest worms in the history of the world. Read about those two things. Then read about io.js and the splintering of the entire Node.js community over some stupid code of conduct. And come back to me, and then we'll talk about why you should use Node or not use Node for your enterprise. I will never touch it. I think it is a disaster. So does the creator. So everybody is porting to Go or Rust because of that. They can't get off Node fast enough. I kind of knew that was coming. I was a big Node person too. Watch Farewell to Node from TJ Hollowaychuk, who created Express. Wrote that in 2014. That's the reason I'm coding in Go today, because I read that Farewell to Node blog. Insert JS from the browser. I agree. All right. So, okay. So let's see. It's prompt. Yes, see mastery. Do you like pancakes? Yes. We keep going. Otherwise, no. And then we print. Do. Can't wait to get a mouthful. Okay. So, learn Golang a second language. I would. Go and Java are extremely profitable. There's so many people porting or supplementing Java's code bases in the enterprise with Go. You can make bank on that, man. Java is the number 2 most highly demanded language in the enterprise. People can say what they want about Java, but it is still in strong demand. And Go is the new enterprise language. There's no question about that. So if you learn Go and Java, you'd be perfectly suited to do them both. Yeah. Yeah, that's true too. Kubernetes is written by a bunch of Java programmers. You can tell. It's got single inheritance. They tried to, it's ugly. But yeah. WASM Golang would be interesting too, but I would rather write Rust WASM actually, personally. Anyway, so we got response equals prompt here. You can like Node.js. I like Node.js. I use it for a lot of things. I think Node.js is a huge steaming pile of disaster that has ruined the world in many ways. And I'm not the only one. The person who made Express thinks the same thing. The person who made Node thinks the same thing. I'm just saying, open your horizons and look at the modern landscape of programming languages. And I think if you do, you'll find that for a greenfield project, that Node is the last thing you want to pick. That's just my opinion. I mean, you're still going to have to use it for TypeScript rendering of React and all the shit that you have to do to get it into the front end. Mostly the garbage collection stuff and the size. The overall size. And another reason I think Rust is going to be good for WASM is because Rust caters to web developers. It has a concurrency model that's akin to the event model that's being used by Go programmers. By Node. This is why on the Stack Exchange, very famously, the Stack Exchange survey that came out put Rust as the most beloved language because a bunch of web developers answered this survey. I guarantee you, kernel developers were not answering that survey. It's super duper beloved by web devs. And I used to put that down, and I don't do that anymore. The reason the web devs love it is because Rust is a serious language that feels in many ways like JavaScript to a bunch of people, particularly the event model. It has, in my opinion, it has horrible concurrency because it's using async await, which I hate. But that's what it's using. And I think for that reason, it's going to be very popular as a WebAssembly language, personally. JavaScript at 10 times more hassle for sure. You get smaller binaries, right? You get the same kind of async model promises and all the stuff that you learned as a JavaScript programmer, and you get strict typing. You get safe compilation times. You don't have any chance of writing bad code that can memory leak, even if you have a sandbox of WASM. Doesn't really matter. And so for those reasons, I do think it's all of the projects that are WASM projects are not going to be very big in code base size. So the compilation times are not going to be an issue. I just feel like it's really positioned well. I think NIM is actually positioned better, but I haven't looked at NIM fast enough to really go there. Concurrency Go is smoother. Absolutely. Yeah. Development in Go is faster. But what I love about WebAssembly is you don't have to care. You can do it in Go, you can do it in Rust, you can do it in NIM. Tell you the truth, it might actually be the dawn of NIM. When WebAssembly finally gets really picked up by a lot of people, and they realize that they can get a Python-esque kind of syntax out of NIM. I mean, my first impression of NIM is it's very, very good. It's all compiled C at the end of the day, and it's much smaller runtime binaries than Rust. Yeah, NIM gives you smaller runtime binaries than Rust because it's just a macro language that gets compiled to C. So I don't know. It's going to be very interesting. WebAssembly is really going to change the landscape, and everybody thinks web development is where everything is, and it's obviously not the main thing. But when it comes to WebAssembly is going to have a huge impact on any of the languages that can be compiled. And by the way, if you're not learning a compiled language right now and you want to claim a place in the front end world, you better damn well learn it, because WebAssembly is the future for web applications. There's just no doubt about that. And if you can't write WebAssembly code because you can't code in anything that can do WebAssembly, you're going to be left out. And that means learning NIM or WASM or Go or NIM, Go, or even C. You need to be able to learn these languages that you can rapidly develop stuff for that. Yeah, it's going to be here too. It's going to be here fast. I push gaming more toward browsers again. I know, which is also amazingly cool. Is what JS should have been 25 years ago. I don't know if I agree with that. I mean, JavaScript was meant to not make applications in the web. It was meant to facilitate, graphs and things like that. I mean, when we talk about the web as an applications delivery platform, WASM makes a ton of sense. When we talk about the web as a method of communication and document sharing, which is a totally different use case, the original use case, by the way, much different thing. And JavaScript's not going anywhere because of that. That he regrets it. He absolutely does. Yeah, Brendan Ike. Yeah, but Yeah, I think I don't think JavaScript will go away, of course, but I think WebAssembly is gonna. The crazy thing about WebAssembly is it's gonna create a whole new fight for territory, because it's all going to be about whose libraries win and stuff, who has the greater library sets and all of that thing, and I honestly I think Rust is ahead of the game on that. Rust and Go. I mean, Go has phenomenal standard libraries. It's just not going to be as, nobody's going to write a web game in WebAssembly and Go. It's a bad idea. I'll be the first to tell you it's a bad idea to do that. They would write it in Nim or Rust though. And that might very well be the resurgence of the gaming world that Rust has been wanting to be a position or a player in, because there will be people writing C++ WASM applications, but it's going to be a much more complicated task. It can be very interesting. That's all I got to say. I don't know. It's not my space. It's not where I'm interested in playing, but it is going to be extremely interesting for sure. On that note, I think we're done with the Waffles game. We've learned everything we wanted to learn in the Waffles game. The Waffles game was designed to just give you more experience with interacting. If you want to say yes, and you can say print do, can't wait to run mouthful, you can do that, and then you can loop through and do it a second time. But that was the fundamental crux of the Waffles game. I know it's very rudimentary, and I've kind of gone off the rails here because we have so many advanced people in here, but just write this. I mean, the primary focus has been learning about regular expressions. It's been learning about, proper prompting techniques. It's been learning about how to save something. Oh, by the way, as we wrap up our program here, let's do some things. Go Java challenges. I don't know. Versus Go and frameworks. I think so. I love Gin. I was kind of against Gin, and I'm super fan of it now. C# is not bad. Anyway, so you remember that Go work stuff? Remember all that Go work stuff we've been doing, right? Okay, well, the Go work stuff has allowed us to run our Waffles program up to now without a problem, right? And stuff. And you can, riff on this all you want. But, okay, now it's time to say, okay, I'm done with my work session, and I'm going to turn it off. So this is how you do it. You move go.work to go.work.off. This is something I do. It's a convention of mine. I still want my Go work file around. In fact, I want to save it with my code. I just don't want it to be in effect. In fact, so much so that I'll usually will put a git ignore in case I forget, right? I'll put a git ignore for go.work. So on accident, if I were to accidentally save go.work, we went through go.work already. I don't want to go through it again. We covered it earlier today. So now if I try to build my code, it'll fail. And that's what I want. Why do I want it to fail? Why do I want my Go install, my Go compile, my Go build? Why do I want it to fail now? We already covered Go work. You want me to cover it again? I mean, you can go back and watch it, but I went through Go work pretty exhaustively. This is for the second time this week. Every week we talk about it a little bit more. And so as you can see, without Go work, Go build doesn't know where to find it, and Go install uses Go build. So it's like, I don't know where to get it. You remember we talked about concurrent package development? I'm like, oh, okay. So by removing the Go work, by moving it, I have just re-enabled these dependencies. I'm like, that's right. I need to go finish those dependencies that I've been tweaking on, right? So then I go back into my other places where I've been doing this work. term. I don't even remember where it is. I think it was, what was it, 19? 19. So we need to go to 19 term colors. So we're going to go into 19 and get status. We've been working on term colors, but we didn't really commit it yet, right? We were like kind of in the middle of developing, so we didn't really close it up and push it. So we've got our testing done, and we've got something worth committing here. So let's do it. Let's say go add term colors dot go, and it will get add term colors. We got our test case. Let's add that. Get status. Now we have our term colors is our changes to term colors are committed. We can actually commit and push these changes. So I can do commit -m, add term colors to term color shortcuts. Okay. And I have a get push. I have a nice granular commit, and that's all pushed. Now watch what happens. When I come back over here, if I do go install command waffles, it'll still fail, right? But I can do go get, and then I can say, I could say -u and it'll get everything, or I can say go get, and I can type the whole thing. GitHub.com, artifacts.rob. I mean, this is a long way. I usually just do go get -u. Sometimes you don't want to do that though, because you don't always want to update every time. Boost weeks 19 term colors. So what this is going to do, because we just pushed our changes to GitHub, right? So they're now published. They're out there for anybody to use. And when I do go get, this updates the go.sum file, which contains the reference to the version. It downloaded it. It uses a dynamic version for now. Because we haven't tagged anything. We haven't talked about that at all, but that's what that's about. So this is a dynamic version that's assigned to any Go package that does not have an explicit tag. Go install is used for installing. Go get is used for updating dependencies to stuff. You should never use go get for installation. That's the difference. So now what? So now when I go build it, and I mean, that's the short version. So it says, okay, go get the term colors. No required module provides package to add it. Does that? Well, maybe I didn't do it right. Let's go see if we can do it right. We shouldn't be getting that error anymore. But does not contain package term colors. What? Let's see. Go boost upgrade found. Oh, wait. I have to. That's right. I have to tell it what version. Yeah, I have to tell it what version. I forgot about that. At 2022, we had that problem last time. Yes, we had that problem last time. So let's try it now. Okay, so we had that problem last week. That's why I remembered. So I had to add the version. This is usually not a problem for you. If I have multiple branches and I had to make sure the right branch was represented, I've been committing to 2022. So that's the at thing, right? Usually when you're doing a go install, by the way, you do go install blah, blah, blah at latest. And you have to have an at the end. It's almost always at latest. All right, so we still have this other one. And let me show you what happens if I try to build this without it. If I try to go get it, what's going to happen? Anybody want to predict? Okay, so we made some changes to the CLI tool, right? We made some changes. Did we make any changes to it? Or didn't we? I don't know. Did we? Get status. Did we make any changes to the CLI tool? No changes. No changes to the CLI tool at all. So there, even though we thought we might, we never ended up actually doing any changes. So all we need to do here is tell this Go module that it needs to use the other Go module. And so we do go get, and you can go get this. You do go get, and then we go to the end of it and paste that. And then I'm going to do at 2022. That's only because I'm on a Git branch. If I wasn't on a Git branch, I wouldn't need that. So that will pull it down, and now it's added it. And you can see that I have a go sum file, which you should save. This go sum file is what locks down the exact version of a dependency at that moment in time. And the only time that is ever updated is if you do a go get -u. And what that will do is it'll go out and it'll grab the latest version. Be careful when you do that, by the way, because that updates every dependency. And you may not want to do that. You may have they may have like released a new version that is no longer compatible with your previous version. So the Go sum file is it goes incredibly intelligent way of locking down a specific version of a module, so that you're always getting the right one. Yeah, it's exactly right. It's package lock without the crack. Absolutely. The only danger there, and it's worth mentioning, is if somebody actually removed that version, and that has happened in the past. Were such a thing to happen, this is really not within the scope of the boost, but if you're afraid of somebody literally ripping down that version completely, you can do what's called vendoring, and you can actually go out and make a copy of that dependency in your vendor directory in your project. Now, we haven't covered that at all, but I just want to mention it. And you'll see that that's somewhat idiomatic in the Go world. In fact, Pike is on record as saying, just copy and paste the code. Is it open source? Yeah. Why don't you just copy and paste the code? Because you should be vetting the code anyway. It's a very opposite opinion of how to do things from the NPM node world. The NPM node world is all about keeping really, really teeny tiny packages and then end up having literally tens of thousands of dependencies on a tons of NPM packages because it's more granular and stuff like that. And it's caused all kinds of problems. And I don't need to cite that. Anybody who's worked with it knows what I'm talking about, and including exceeding the total length of a path on Windows, which was really funny. It's cleaner than avoiding duplication at all costs. Exactly. And when you do that, by the way, you're also eliminating a dependency. And in the Go world, the community is more about removing unnecessary dependencies than it is on maintaining. Dependencies are the source of frustration and latency during building. And as we've seen with NPM, overwhelmingly major security flaws. So, you really want to consider your dependencies carefully. And that's my message. That's the message for here. But that's related to go.sum, right? And so that's, just know that it's not considered bad in the Go world to literally copy and paste from a function if it holds you back from having, you need to do the proper licensing and make sure you give proper licensing credit if you do that. But that is considered better, more idiomatic in Go than in any other language culture that I've experienced, because it's safer and it locks down that version. Well, what if there's an improvement to the thing? Well, if there's an improvement, I'll find about it and I'll study it and I'll put it in my code, which is the responsible thing to do, not to just, go get -u or do npm upgrade and pull down any updates that have ever happened by anybody who may have had access to that person's io.js or, whatever Lodash file, which have then just, stuck a worm in all of your code that depends on that package. It's a better way to go about things, in my opinion. And I suggest you strongly consider it. So we are set to go, and we are good to go. We can actually commit everything. We got waffles here, and we didn't have our worker on, so we've got a legitimate version of the waffles program with all of its proper dependencies captured on file. And yes, I do. And then we should probably put do, but I'll let you do that. But copy and paste in C is pretty normal. Yeah, and Go as I mean, look, if you go out to the main site, go.dev, what is Go? And they say it's a faster version of C. It's like, the Go command, go check some Go modules, companies that use Go. I'm trying to find the other one. Why Go getting started? What is Go? I can't remember where I read it, but it basically said Go is a modern version of C, and it kind of is. Yeah, and that's the reason people love it, is because it is so heavily inspired by C. It's taken a lot of the so is Rust. Rust is inspired by Node as well, which is kind of weird. And I'm not a fan of that particular part of it. Anyway, so this is pretty much the end of this stream. We're kind of ending early here, but I feel like you have a lot to deal with here. Let's go ahead and update the documents here. I think Rust is more inspired by Node than C personally too, but I don't think I've ever read that. What was the balance between pulling a dep and copy pasting? The difference between pulling a dep and copying and pasting is pulling the dep is dependent on that dep, the people who manage that dependency. And in the case of the NPM worms, people's accounts were compromised, and those dependencies, so critical dependencies like Lodash, were replaced with malware. And so all the people that depended on those things and happily updated to the latest version propagated a worm to tens of thousands of machines. Worst worm in history through that. And so I hope the world has learned to not blindly accept those who provide dependencies. Something that's just because something is a dependency in your code at one point and is safe doesn't mean that that dependency with the same checksum is going to be safe at a later date. And by the way, NPM didn't even fucking have checksums until how long? How long did it take them to even add checksums to the entire project? That didn't even come for like 2 or 3 years until after NPM had already been a full thing and adopted by everybody. Yeah. So, do with the creators ago. Well, Pike and Thompson worked together with Richie and those guys. Yeah, Pike was really just a junior kid at that time, though. So yeah. No, it's not. Yeah. Yeah, I don't know if they would say that. Their concurrency model has been emphasized by it, but yeah, I can't even. They didn't even have checksumming of their packages until like really late in the game. Schuler rushed the whole thing out because he wanted to get rich really fast. And this is why, and I'll go on record saying this, I think Isaac Schuler is one of the worst IT professionals who has ever seen the light of the IT industry. And if you want to cancel somebody, cancel Isaac Schuler. Because that guy, for the sake of hard, cold cash, rushed shit out for NPM that caused a disaster in the industry. And if you don't understand what I'm talking about, go do your research for yourself. He pushed shit out that should never have existed. He cut corners, and he got Joint to come in and pay him all this money, and he became a board member and all this other stuff. He made his money, and then he got out. And Ryan Dahl actually publicly said, I regret ever letting Isaac Schuler anywhere near NPM or my project. Go watch 10 Things I Regret About Node, where he says that very thing publicly at a Node conference. And I was there. I watched the whole thing from the sidelines. I was like, man, I'm glad I'm doing Go now. So, it was such a disaster. Go look at the IOJS fiasco. It's such a pain. I'm sorry. I have nothing good to say about Node. I have nothing at all. It's just a disaster. Ryan Dahl is an amazing person. How about that? I love Ryan Dahl. The reason I love Ryan Dahl is because he has so much courage. He's such an experimenter, and he has the courage to go in front of everybody and say, I screwed up. Here's how. And I'm trying to fix it. And I encourage you to help me, make changes and fix it. And everybody's, jaws are on the floor. Is like, wait, did he just own that in fact, he just made a huge mistake and he was having fun and all those cute things that he did? You should never do those things. That's exactly what he said. What's IOJS? Exactly. Anybody who lived through IOJS I guarantee you they will remember it. All these companies that were building everything, all this enterprise software on Node.js, and all of a sudden Node.js stopped existing like that. Overnight, over a fucking code of conduct. Because they say, it's, okay, I'm sorry. I got to stop talking now. We're supposed to end this stream. We're supposed to be like happy and stuff. What is garbage collection? And stuff. Random banter about languages and their usages. So that's pretty much it for Beginner Boost Week 21. I told you I'm very random, and I get hot under the collar and stuff like that. So, and he never meant for it to take, just like Minecraft was never meant to be a serious project. So, I don't want anyone to feel personally attacked here, except for Isaac Schuler, who's a total asshole. Probably a wonderful person in real life. No, not really. He's a money grubbing asshole. Unless he's changed from that. I'm sorry. Okay, I attacked one person in this stream. Sorry. Everybody else, you know. Okay, I'm gonna end the YouTube stream before I get myself in more trouble.